Tonight's discussion presentation will be on air purification, ozone, and UV. This was something that Joanne had requested. We touched on the ever popular sharper image ionic breeze at one point when we were discussing, I think it was spectroscopy, and I was bringing up ozone, and then I lambasted the ionic breeze as an ozone generator and why sharper image basically went under, and all they are now is you can pay to have that brand on your product. It's not really a separate company anymore. It's just a branding label. So that's where it started from. So I went out and looked at all the details of what air is and what are the things that are in it and what you want to get rid of and how you can get rid of it and how that is related to ozone generation. And with the current pandemic issue, it's also a matter of sanitation using light and UV, and what kind of UV, what wavelength, and and then how they've been doing high energy sanitation of things for a long time, and whether you realize it or not, and without your approval, they've been sanitizing your vegetables with cobalt-60 X-ray radiation for a long time. And whenever you go into a doctor's office, like a dentist, and he freshly opens his metal instruments to use on you, and he says, "Oh, those have been sterilized." They use an autoclave on them to get all the gunk off, but then they sterilize them using gamma radiation. But that's just how things are done, and people just aren't aware of it. So we may be exposing some things that might give some people nightmares later tonight, but it's what I do. But first, we'll cover the news. So when we were talking about satellites and how there's much bigger, okay, a couple of sessions ago when we were talking about constellation satellite systems, and how I was pointing out that there are these very, very large satellites that they keep putting up there every 5 to 10 years because they run out of fuel and they got to go put them in a parking orbit somewhere. The USGS is having NASA launch the Landsat 9 satellite. It is so large, it requires its own Atlas V with side boosters. So you're talking multi-tonnage satellite. It has an enormous set of solar panels, and it sits there up in the sky at geostationary. It orbits, but it orbits at the same spot all the time, and it takes pictures. Well, they're going to launch one of these suckers again, and so the next time you're talking about all those nasty Starlink satellites out there, a Starlink satellite is about as big as one of the subsections of one of the major sections of the solar panel of this particular satellite.
Is that the size of a small car?
They described it as it's as large as a Greyhound bus.
That's as large as the new things going up there, but I was talking about the Skylink.
No, these Starlink satellites,
I heard an interesting thing this week in that the fact that where the global warming is warming up the atmosphere is causing some of the satellites to stay up there longer, so we'll have more space junk up there.
Well, these geostationary satellites that they put up there, they stay up there essentially forever. They park them over in a parking geostationary orbit, but even when they run out of fuel and their electronics die, they're going to be up there for hundreds of years.
Might outsurvive us.
Well, every 10 years, they put up a new generation of satellites. I'm waiting for I just changed the content on Facebook Live. I'm waiting for it to catch up. They're going to launch another Landsat. This will be Landsat 9. The last one they launched was, curiously enough, Landsat 8. So there's a bunch of these things up there. They've been launching these Landsat series satellites for about 50 years now. Every 10 years or so, they need to launch another one because they run out of hydrazine fuel for their course correction and therefore cannot keep their geostationary orbit maintained. So they send them over to a geostationary parking orbit, and then they bring up the next generation satellite. These are so large that they require an Atlas V with side boosters. It's not leaving the planet, it's just getting to geostationary orbit. So you're talking about a satellite that has multiple tons. NASA identifies it as about the size of a Greyhound bus, one satellite, one rocket to launch it. So the next time somebody's talking about how all the big satellites are up there, this is one of the big satellites. Okay, another launch coming up in the not too distant future is Lucy. Lucy is not an acronym. Lucy is named after our predecessor, Lucy. And Lucy is named after the Beatles song, Lucy in the Sky with Diamonds. So I don't know why they need to capitalize it all. It should be uppercase L and then lowercase UCY, because it's a name, which they've got here, but on the patch, it's all uppercase. So what Lucy is going to do is be launched. Let's see, I think they have the date here. I sent out a bunch of links. Okay, here we go. It's scheduled to launch no earlier than, which means it could be launched later than October 16th. It'll be launched from Cape Canaveral Space Force Station in Florida, and it will be launched by an Atlas V, a big rocket. They're running out of these because they're no longer making them. They're the ones that use the Russian engines, and the US Congress has banned ULA from using the Russian engines. You have to go use the Blue Origin engines that are not available yet. I've never flown yet. So once they're out of ULA Atlas V rockets, they're gonna have to find a new way to launch these things. So anyway, Lucy is going to take a lot of years to get to the destination. Lucy is a combination asteroid belt and Jupiter Trojan asteroids explorer. So Lucy will do a couple of gravity assists to get out to the asteroid belt, and then we'll go beyond there to get to the L4 and L5 Lagrange points of the orbit of Jupiter around the sun. And that's where the Jupiter Trojan asteroids hang out. And that's its mission, is to fly by those and do studies of them. Now, Lucy will be moving way too fast to go into orbit around any of the asteroids in the asteroid belt or any of the Trojan asteroids around Jupiter. Well, in orbit with Jupiter, not actually orbiting Jupiter, but in solar orbit with Jupiter. So it'll be zooming past them and taking pictures. It is not nuclear powered, it is solar powered. So it has large solar arrays. That's these two large round petals. And it does not use ion propulsion, which was a bit disappointing. It uses hydrazine liquid fuel propulsion. So when Lucy runs out of hydrazine fuel in a little over 10 years, it will be on a looping orbit between one of the asteroids in the L4 and another asteroid in the L5, and it will just loop there until the solar wind pushes it out of orbit, and where it will go after that is anybody's guess. So that's Lucy. It's going to launch soon, but you're going to have to wait a lot of years before you start seeing data back from it. Another NASA event is, in order to promote the James Webb Space Telescope, NASA is going to have a STEAM virtual day event. That's science, technology, engineering, arts, and math. That's how you get the STEAM out of STEM. And it's for educators and students, but you know what it's really going to be? A lot of, have you heard of infrared? Let us explain infrared to you and why it's important, and show you what the Webb can see. And I was on the James Webb Space Telescope training session earlier this week. They actually held two sessions. Helen and I were on the first session, but because I had a spare hour, I popped in on the second session, and I did suggest a few things, like some of the people that are actually going to be doing the STEAM event and the James Webb events prior to or after launch had never heard of the NASA JPL Night Sky Network. And I said, they have a lovely demonstration that you can watch involving a black garbage bag if you have one of those infrared cameras. And so that led to a lot of discussion about that sort of thing, because it's a good demonstration of how infrared is something human eye cannot see, but some electronics, not all, Apple, can't see. And somebody had already tried that and said, every time I try it on Zoom, I can always see the infrared remote control light. And I said, that's because your webcam is infrared sensitive. Oh, okay. I said, what you need to do is hold up your phone, shine the light into your phone, and let the Zoom see the reflection off of it, not shine it directly into the webcam. Because if you shine it directly into the webcam, it will see it. Button. Let's see. Find the right camera. There it is. But see, my webcam can see the infrared. That's that purplish blinky thing. So it's only the insufficiency of human vision that says you can't see the infrared. And Adam actually pointed this one out to me. NASA JPL does these kind of day in the life of NASA things. And they did one on kind of a day in the life of the Perseverance rover and the Ingenuity helicopter, and what things they found and what new conclusions basically planetary scientists are coming up with. And this is the, gee, Mars was wetter than we thought for longer than we thought, and it dried out slower than we thought, but we're not going to find any water on Mars. Really? You know, in light of what you're finding, how can you still say that? You just have to dig deep enough. And there's always the naysayers, the doom and gloom of Mars was always doomed to lose its water. It's just not big enough. Like, okay, so which do you think is bigger, Mars or Enceladus? Well, obviously Mars, but Enceladus is much further out in the solar system. So its liquid water, a salty ocean, we believe, is under a mile or so of frozen water, ice. So, you know, whenever somebody absolutely stands on what they think is solid ground and proclaims, never, that can never happen, it'll never exist, all you need to do is just go find another example and go, are you aware of that? You know, it's kind of like when I tell my amateur radio astronomy folks, I'm building this small antenna for use with dirt cheap radio astronomy observatories, and they go, oh, you've got to have, you know, a 4-foot dish antenna to pick up pulsars. I said, really? What size antenna is in your cell phone? And they pause for a moment and they remember the early days of cell phones that had the rubber ducky antenna that was, you know, that they started out about 18 inches long, and then they got shorter, and then they telescoped, and then poof, in one generation, the cell phone no longer had a visible antenna. That's because they use something called a fractal antenna. It's just a little tiny piece of conductive material, and it's cut out into a snowflake-like pattern, and that works fine.
The new iPhone is supposed to have some sort of satellite capabilities to be used in emergency situations with low-level satellites.
I don't know how valid that would be. I don't know that they can transmit at the correct frequencies.
That's what I was reading up on it. They announced it in China.
I'll have to look into it. Let me make a note of that. Sally, are you still running the Facebook page?
No, I'm not running the Facebook page. I'm driving up I-95.
Okay, because I'm hearing an echo in the background.
Well, that might be the car engine. That's why I
No,
put it
my
on
voice.
mute.
I'm hearing my voice echoing in the background.
Oh, no. Not me.
Okay. And while we're talking about Mars, there's a lander, not a rover, a lander that's been on Mars for some time called InSight. And it has these two giant solar arrays that look like flower petals. And since it doesn't move around and it can't wiggle the panels, Martian dust tends to collect on the panels and reduce its electrical generating capability because unlike Curiosity and Perseverance, it's not radioisotope thermoelectric generator powered, so it's not nuclear. So what they found out was if they take the InSight lander's arm and they scoop up some dirt and they sprinkle the dirt on the solar arrays, and the next time the wind comes through, the wind tends to stir up the pattern and actually clears off the solar panels. So they restored their peak energy on the solar panels by liberal applications of dirt. And they now have enough electrical juice to start doing some observations again. And they detected 2 Mars quakes. I want to say earthquakes, but they're on Mars, so they're Mars quakes. On a planet that supposedly has no tectonic plates and a hard core, not a molten core, there were 2 quakes that it detected, one of magnitude 4.2 and one of magnitude 4.1. And they had one quake that actually, the 4.2 one, that continued for an hour and a half. That's not just like, some rock pieces adjusted themselves. That's something moving for an hour and a half. So it'll be interesting to see how science changes itself from Mars has no molten core. Mars doesn't have a rotating core. Mars has no tectonic plates to, how do you explain them there earthquakes? Well, something hit Mars. Okay, I can buy that, but an hour and a half duration? They say we come up with new science all the time, and so maybe they'll come up with some new science to explain how they got it wrong for so long. And it's time for the valet parking shuffle aboard the International Space Station once again. The Soyuz capsule will be moved from the front to the back in order to make room for another capsule coming up carrying the next shift of crew. I think it's going to be another SpaceX Crew Dragon bringing a few people on board. So they're going to move the Soyuz to the back, and then when the Crew Dragon shows up, there'll be a little bit of overlap at which they'll probably have 6 or 7 people aboard the ISS, and then the Soyuz will land its crew back on Earth, and then at some point when they want to bring up the next craft, the Crew Dragon will have to go to the backside and move it to the front side. Now, you might think, well, why do they go through all this shuffling? If you remember back to the Apollo Soyuz, we came up with this docking adapter that was a universal docking adapter. But the Achilles heel of it is, it wasn't universal. It was basically a tunnel that had a US compatible docking adapter on one side and a back then Soviet Union, Russia compatible docking adapter on the other side. So they just called it universal because it had each preferred kind of connector on each end. So they could dock. Well, the space station doesn't work that way. So the Russian modules have Russian compatible docking ports, and all the other modules have US compatible docking ports. So depending upon which craft is coming up at what time, some have to move around to the backside. Now, why don't they just park the new one at the backside? And it's all a matter of safety and fuel. If you've got to fly above the ISS in order to dock on the backside, that requires more fuel on your way up. So why waste the fuel? Dock on the side closer to the Earth. And also, if something goes wrong, for those of you that are into golf, you'll always know that when you're on the putting green and you putt through the hole. That way, if you're ever off, you can come back along the same line. Well, the same thing is true of the International Space Station. If your capsule is on its way up to the space station, you fly up to the docking port. You don't go up and around and come back down, because then you're changing your course direction. So they come up, dock, and then when they need to get out of the way, they move, which is a relatively easy thing to do. Just back away, and now you can go up. You already have all the ISS momentum in your velocity, so you're traveling with the ISS. It's pretty straightforward to go up there, dock, and then when you want to come back down, you pull away and you slow down, and the ISS goes and you start descending. So valet parking maneuvers. Okay, this one's for Joe. In our discussions last week, he brought up tetraquarks. Quarks are subatomic particles that make larger subatomic particles. And the normal form of subatomic particles made of quarks are 3 quarks. And you can get 2 ups and a down, or 2 downs and an up, but you don't get 4 quarks. Well, there is a stable form of matter that can actually be made from 4 quarks, but you don't find these in nature, but they can be man-made and they become stable. So you have tetraquarks, tetra as in 4. But if you carry it to the next level, you get, okay, what's after tetra?
Quinta?
Pentaquarks.
Penta.
Now this is just an example of, under the right circumstances, you can get quarks to coalesce into things that nature never intended. So you can actually have 2 quark gluons that, when they join together, you can temporarily, this is not long-lived, they're man-made, you can temporarily have a pentaquark.
So
But,
the whole deal is that they can have a matter and antimatter pair that cancel themselves. And so you end up having the exactly 3 triad of quarks.
a
There,
penta,
the outside is a matter antimatter pair. So they are there, they exist in that specific moment, but they are going to cancel themselves and going to be just a triad quark. So it's basic when you have a quark that's more than the normal number, that is always a pair of a quark that is a pair of matter antimatter that's going to be, in the way there to kind of keep the balance. But it's basic, like generally, 3 kinds of matter quark.
Do they
Yeah,
have
but-
hypothetical thought of what they're going to use these for, that they're trying to develop them?
No. What they're doing is, these were all found by the Large Hadron Collider, the B instrumentation. B stands for beauty. Remember, quarks have these beautiful things like charm and strange, and they give them all these beauty characteristics. So these were found by the LHC B instrument. And what it's doing is it's looking for all of the very exotic forms of condensate matter. So when you have 2 protons collide, it spews all of these subatomic particles out there, and a lot of what it spews out there are quarks. And then what the instrument does is capture all the data and go, look at what we found. Look, it's a tetraquark, and it's stable. And what's it comprised of? Quarks and antiquarks, but there's always a pairing of the same type. But when they got to the pentaquark, they said, it didn't last long, but boy, was it interesting while it happened. Because when you have 5 of something, there's an odd man out. It's an odd number. It's not an even number. So
And when you get 2 quarks 2 up quarks, 1 down quark, you get a
That's north,
proton.
three
No,
quarks.
blue ones are what keeps the quarks together. Or probably you mix it with something else. So
Right,
you have
right.
like all those particles or that has mass, they're made of quarks. And then what keeps them together is the gluons. It's gluons you could think about is almost like a tunnel that keeps them together, or like a spring that keeps them together. And then if you stretch the spring too much, you give so much energy that you end up making another pair. So you actually create the pair. So you can never see a quark outside of hadron. And they always inside of them because they cannot exist by themselves. So if you stretch enough, you make another particle. You make another pair.
That is until we find out what is inside of a black hole.
Yep.
And
Or
it wouldn't
what's on
surprise
the
me to
outside.
find that, it wouldn't surprise me to find that given that a white dwarf, when bigger, degenerates into a neutron star, and then a neutron star degenerates further. And if you get a big enough one, you get a black hole. But if it continues the path of degenerate matter, the stuff that's in the core of a black hole could just be a whole lot of quarks. So we don't know. No way to measure it given our primitive technology.
Well, they're getting better all the time.
Yeah, I'm willing to give them more research funding to, break things apart even more and look further. So this one was from, I think, Sally. The volcano that happened on the island of La Palma in the Canary Islands, there's been this long-standing disaster prediction that if the volcano blew itself apart and the entire western side of the volcanic mountain slid off into the Atlantic Ocean, there would be a mega tsunami. And apparently this latest eruption basically poked a hole out the top of the volcano and then poked a hole out the side of it and never actually blew off the entire side of the volcano. And therefore there is no mega tsunami threat from the current eruptions on La Palma.
So I can visit.
Yes, it's still safe for you to go there. If you remember, there was an episode of Star Trek: The Next Generation where this alien of infinite power and his wife were living in the only house that survived a military bombardment of an entire planet. The same thing happened on La Palma. Apparently, there is a house on La Palma that happened to have the right ridge height all the way around it, and the lava literally went around the house. So you see this house with like green shrubbery all around it, sitting in the middle of a pool of lava. And they're saying that eventually the house, if there's any wood or anything in it, it'll catch fire and burn to the ground, and all of the plant life will go away, just because there's several thousand degrees of heat sort of in the neighborhood.
No, I don't think so. I think it has a force field.
Yeah, well, that's why I was mentioning the Star Trek Next Generation episode. There's an alien that owns the house, and he didn't want it to be lost to the volcano, so he protected it. He won't let the lava come in. If you've ever seen some of the attempts to hold back lava in the Hawaiian Islands, they're kind of comical. When people first start doing it, they'll do things like, if we spray water on it, that'll make the lava harden, and therefore it won't go any further. And they forget about the sheer rock mass of the moving lava. So even if you harden a crust on it, it's still coming. So they put up several layers of cement J rails like they use for traffic barriers on highways. And it shoves the J rails along the ground. There's just that many tons of molten mass that is the lava. So when lava wants to go somewhere, you get out of the way, it just goes there.
Monroe, why is that a floating a little square of the last person who talked instead you? Right in the middle of the page. There is something wrong, like it's blocking the whole page where you're showing.
Is it
No, you
gone
did it.
now? That was to avoid me doing this. That's the Zoom live video there. Yeah, I need to find a way to do that because all the other controls are on the other display, and I'm looking at the main display that's big enough so that my geriatric vision can see it. But that's what was sitting there is the live video.
So on National Public Radio, they were saying that Spanish tourism is trying to recruit people to go to La Palma, saying that although many people have evacuated, that's just part of it, that it's really safe and they're encouraging people to go. And if it weren't for my personal situation, I for sure would go and see a
Well, the Canary
volcano.
the Canary Islands consist of more than La Palma. So where did all the people go when they evacuated La Palma? Well, they went to some of the other islands in the Canary chain. There's no volcano on them. Well, there are, but they're dormant. Occasionally the volcano on La Palma spews for a while and then subsides, and it subsides just long enough that the locals go, oh, good, it's time for me to build back my house again. And they build back a house on the same plot of land, knowing full well that when the volcano goes burp again, they lose another house. But look at it this way. Their new house is going to be on higher land. People,
More minerals for farming.
yes. Oh, it makes good soil. I guess it's good for growing coffee.
It becomes very valuable land.
Yes. Juan Valdez would say it's good for growing coffee. So that was a news item that we talked about, which was a follow-up to a ad hoc discussion item from a while back. And we have another one of those things coming up, which is laser turntables. So there was a resurgence in people wanting to listen to vinyl records, I guess because they have so many of them and they have a fondness for antique technology. So a while back in the 1970s, somebody took a laser and attempted to create a beam follower that would follow the actual grooves in the vinyl record. And when they said, we think we can do this, they came up with a prop demonstrator. And then the following year, they actually had something that did it. So what do you think the Achilles heel would be of a laser that can read the grooves of a phonograph record?
Was it melting it?
No, it was infrared. It did not have that much power. It was actually less destructive to the vinyl than playing it with a mechanical needle. The problem was, as Bugs Bunny would say, it's too sensitive. It was picking up everything. So it was actually picking up noise that a needle never detected until they really amplified the hell out of a needle's audio and found that there was needle rumble. I mean, the needle is on an arm and it's got a certain amount of pressure to keep the needle in the groove and to have the needle bounce up and down, equivalent to the audio oscillations ingrained in the vinyl. Well, the laser could see all the way into the bottom of the groove, and down below where the needle would be riding on the two side walls, there was all this gunk left over from the cutting and pressing of the record. So it was actually interjecting pop and hiss and all kinds of just ratty trash in the audio track. And the other thing was the laser is very precise, whereas the needle had a minimum diameter that it would find as meaningful to transcribe the sound. So what would be smaller than the bumps on the vinyl, but big enough that the laser would pick it up. dust, smoke particles. The laser was picking up all of that and adding it to the audio track. So when they first came out with one of these, they wanted to charge people over $10,000 for one of these laser turntables, and they thought they were going to make a fortune. And then people heard, and they said, it's not worth it. I've got to run, more electronics after I pick up the sound to clear all the junk out of it. So how do you make it where it's no longer as susceptible? Instead of using two beams, one, you split the beam and you make one for the left channel, one for the right channel. You use like an early CD player. You use multiple beams, and the beams are actually tilted so that they are angled into the side walls of the groove. And now you can stop picking up all the junk in the bottom of the groove and start picking up just what's on the inside walls. But that made the whole head pickup assembly too big, and it made the turntable too expensive. And however, somebody recently came up with the idea of, well, cameras are high enough resolution now. Why don't you just take a picture of the entire record and then use software to go back and post-process the high resolution digital image into what the soundtrack would be? So laser turntables are too sensitive for their own good. It takes too much processing, makes them too expensive. However, if you take a 50 megapixel camera and you place it directly above the turntable, and you take a very bright lighted image of the turntable, you can then go back and take the picture of the record on the turntable and decipher all the grooves. I think that would be just peachy, because you only have to take the picture once. So, as I say, put a push pin in this one and let's see how far along they get with this. But it may be fascinating in the near future. So, a way to preserve your old vinyl albums might be just take a picture of them and post-process the sound into an MP3. Thanks, Joe. I found that interesting.
Me too.
And I posted the What's Up with Helium on the Broward Astronomy Facebook page. And I found another use for high quantities of high purity level helium. Gravity wave detectors. Well, if you think of LIGO and Virgo, these are very large instruments. They've got linear tunnels that go on for miles in sort of an L-shaped two directions. They're enormous. So you're not going to build a lot of those because they cost a lot of money. However, over at the university in Leiden in the UK, they found that if you build an aluminum copper sphere that's perfect, and you suspend that sphere in liquid helium that is a few millikelvin of absolute zero, that the distortions of it can produce an electrical signature. I mean, you're talking, nanoamperes, but an electrical signature that is representative of those high frequency gravity waves that they're building all these fancy new detectors for. But each one of these detectors, the sphere is only about 6 inches across, but it has to be ultra precise, and you put it in a tank of helium-4 and helium-3 mixed. The predominant content is helium-4, but you put a little bit of sprinkling of helium-3 in it. No normal helium, no helium-2. It's got to be lots of helium-4, with a little sprinkling of helium-3, and then you actually you put it in a U-shaped tube, and the differential of the helium-3 being balanced out in the tube causes your sphere chamber to get closer and closer to 0 Kelvin. And because of that, any distortions of the sphere produce an electrical field, because it's copper and aluminum. It's copper aluminum alloy. And you put that inside of one of these metamaterial inertial management things that measures magnetic fields, and you can measure the nanoampere level changes in the sphere, and those are representative of high frequency gravity waves. And strangely enough, when they got this thing working, they had a devil of a time getting rid of all the gravity waves they were detecting, because almost near continuously they were detecting gravity waves. And if you remember LIGO in its early days, it was so sensitive and not sufficiently isolated that it was picking up what it thought was gravity waves, and it turned out to just be airplanes flying overhead or vehicles driving on the highway, miles away from the detector. And once they found out ways to suspend all of that stuff to isolate it, then they really started detecting genuine gravity waves. But I'm assuming that given all the history of LIGO, that these new detectors at Leiden have already done all that stuff. So what does that say if we can sense all these gravity waves? Are they all neutron star mergers, black hole mergers, or is it something else? And I think it's something else. I think once you give up on trying to modulate the electromagnetic spectrum, you learn to modulate gravity waves and use them for communication. But until we come up with the technology for a demodulator, we won't know what these near continuous gravity wave signals are. So another push pin. Put a push pin in. Get back to it. So that's all I had for the news. Any other news? One thing I'll point out is that for those people that have watched Physics Girl on YouTube, she's got a whole new angle. She separated herself from PBS, and now she's doing her own educational videos, and then she's reselling the videos for AP 101 classes. So if schools are doing virtual AP 101 sessions, they can actually pay Physics Girl to just, play her YouTube channel videos. And the earliest one she did, she's now letting out to the general public. So there's some pretty good stuff out there. And
I like
knew-
the first one very much, because she showed the mud geyser that moves.
oh no, I'm talking about AP 101 classes, traditional physics classes.
Mhm.
She's now doing those as part of her stick on YouTube, and she's selling the training videos. And then once she's sort of made the revenue she expected off of them, she puts them up on YouTube. And since her videos are popular, she gets a little piece of little slice of the action from YouTube for showing them. And I was watching the one on gravity and orbits, and a thought came to me like, I need to do the calculations and determine what the Earth's gravitational pull on a 1 kilogram nanosat would be in the mesosphere. So if you have a rocket, get it up to orbital speed and then let it go, and it orbits the Earth at that speed, and it uses something like, I don't know, photonic propulsion to keep itself in orbit. Could you have a probe that will orbit within the mesosphere? Because satellites can't orbit. They're going too high, too fast. Balloons pop before they get there. So it's real hard, aside from looking through the mesosphere, to understand what's there. I think there's a lot of helium there, but we won't know until we get something in there to start mining it. Welcome to tonight's session. It's on air purification, ozone, and ultraviolet radiation. And the ultraviolet is referring to UV sanitation. So this was something that one of our members suggested. And I said, sure, I can learn about that stuff. That sounds like fun. There are creatures on Earth that consume air, breathe in air and respirate and basic stuff like that. But the stuff that we call air is not a single elemental gas. It is a mixture of things. Only about 20% of it is diatomic oxygen, or O2. It's diatomic because it comes in pairs. It's not just oxygen as one atom. It comes in pairs. About 80% of it is diatomic nitrogen, and the remainder of it is inert gases, argon, neon, krypton, and radioactive radon. So 100% oxygen is not good to be breathed for extended periods of time. The oxygen that they give you when you're in the hospital is not quite 100% oxygen. It's got a little bit of mixture. It's high percentage oxygen. And you have that on people are on that for a while. They use it in ventilators for people that have cardiac and lung problems. They can walk around with oxygen separators that will break out most of the oxygen from the nitrogen. And they don't worry about the inert gases that you're breathing because they're inert. Some of them are ERT though. Spies Like Us movie. Yeah. So the US government has determined what the acceptable levels of certain gases are. For carbon monoxide, it's 50 parts per million. You'll see this unit of measure called ppm. Carbon monoxide is the stuff that if you breathe it out of your car exhaust, it will kill you. If you have a fire indoors, kind of like somebody creates a fire in their fireplace and forgets to open the flue. If you don't pay attention, you can suffocate from that. And then our ever popular friend, carbon dioxide, which anytime you burn up or combust anything, you get carbon dioxide from it. And the safety limit for CO2 is 5,000 parts per million. So a lot more, but that's an easy to come by number. Later on in this presentation, I'll show you the air quality meter that I have in my kitchen at home, and I can just breathe on it and watch the numbers rise and fall. So if you do have one of these environmental detectors in your house, and you do something like, I don't know, bake something in the oven or make toast, the burning of the material in order to get that lovely crust on the outside or the crispy taste, that produces CO2, and that raises the CO2 levels. CO2 is actually used to euthanize poultry and swine. They thock cows on the head, but apparently it's too much like effort to do that with poultry and swine because we want to whack out so many of them at one time. So we just euthanize them by using high concentrations of CO2. One of the strange side effects of being poisoned by carbon dioxide is your blood gets very, very bright red. So I guess when the poultry and the swine get bright red, sayonara. But yeah, there was a lake that had a volcano beneath it, and the volcano didn't erupt through the lake. It just sent up gas bubbles, and it was sending up carbon monoxide and killing people because the area that they lived in was inside the well of the crater of the very much larger caldera. And then from machinery, the ever popular burning of fossil fuels, we get things like nitrogen dioxide. Now, bad levels of that are even smaller, 100 parts per billion. So nitrogen dioxide, you don't want to let a lot of that in. I'm guessing that the fact that it has nitrogen and can suck in and make into compound oxygen, it robs the available oxygen and you can't breathe. So not good to have a lot of that in your air. So what does it mean to purify air? Well, what do you want to remove from the air? Because you know, if you're into removing all the gases except the sweet oxygen, you're probably not going to do well with that because, you know, consuming just pure oxygen is not good for you long term. Human beings actually have built-in particulate filters. We have a nose that has follicles inside of it. We have ear hair. We have eyelashes. Our Our air passages are moist and they have microscopic cilia. So we can take in a lot of particulate in the environment and it not cause us a lot of problems. Where you do run into problems is when people have problems like smoking, drinking, allergies, asthma, bronchitis, pneumonia, COPD, and the list goes on and on. They may not be able to tolerate high quantities of particles in the air. And it's not just the size of the particles, it's also the quantity, the density of the particles. We'll get into filtering particulates. Large particles are fairly easy to get rid of. Smaller ones are also pretty easy to get rid of, but it's the microscopic, very small, the nanoscale particles that are difficult. You can get rid of non-radioactive gases. There's ozone, there's O2, there's carbon monoxide, dioxide, there's formaldehyde, which sounds like a really big, horrible chemical, but it's just carbon with oxygen in a different flavor. But human beings have these built-in gas separators called lungs. We take in this mostly nitrogen with some inert gases and oxygen, and we separate out the O2 that we need, and then we take the carbon from our bodies respirating the oxygen, and we spit that back out as some carbon monoxide, but CO2 mostly. And then there's the radioactive stuff that's in the air, radon. It comes in kind of two things, the radon gas, but also fine particulates that have radon as a part of them. And if you have enough radon, what you're going to find out, there's only a couple of things you can do. Seal the points of entry. So if there's a lot of radon in the neighborhood that you're living in, you can try and seal it out, seal up your home. But if there's too much in the neighborhood, it's going to find a way in. And if it's too high, it may be just time to find another place to live. And if you do the property value assessment and they find the radon, the property value of your house is going to decline. So I guess if you've never had a problem with it, if you go looking for it, you may find that it's a problem. So filtering particulates. So you can have large scale filtering, which will filter out the water vapor borne particles that carry bacteria and viruses. But if the air is dry, because you've got a good recirculating air conditioning and it's also acting as a dehumidifier, then the size of the particles that you need the filter to take out gets smaller. There are these things called high efficiency particle filters, HEPA filters, and you can get either just basic ones that are just fine filters, or you can get them to be statically or ionically charged with activated charcoal that will filter even more, because the small particles want to static cling to the activated charcoal, fill little pores in them. So a good HEPA filter should remove particles down to 0.1 micron or micrometers. It should be effective to 99.97%. Unfortunately, the SARS-CoV-2 virus is slightly smaller than 0.1 microns. So your HEPA filter will not filter the virus itself. Luckily, the virus is not airborne, and it is carried on moisture, on water vapor. And since your HEPA filter can filter out the water vapor, it gets rid of the virus by getting rid of the water vapor, not by filtering out the virus itself. It's too small. So when not carried on water droplets, most bacteria and all viruses are micron sized and can potentially go right through the non-static or ionically charged filters. So you definitely want to filter that has some of the stuff that will make the clinging occur. But a filter of this kind does not remove dry gases. So you can't filter out carbon monoxide or carbon dioxide with a particulate filter. Gases are smaller than that. It's not going to remove them. So you need to do something called scrubbing, which is where you find a reagent that loves to suck in the gas that you want to get rid of, and it combines with it, and that's how you get rid of it. Scrubbing. So you can either use what is referred to as a filter cartridge or a canister. This is a material that you'll put inside the container, and then you, under slight pressure, move the air you want scrubbed over it, and then the compounds in the air will chemically combine with the compounds in the scrubbing material to remove it by mixing with it and making more complex compounds. So you probably have heard of a number of compounds like washing soda, which is sodium carbonate, or baking soda, which is sodium bicarbonate. These are not the scrubbers. The scrubbers are calcium carbonate or sodium hydroxide, which is also known as drain cleaner. So sodium hydroxide, lye, and calcium carbonate, also known as calcite or limestone, which is also an acid. They're good at removing CO2.
Yeah, but do you need to stir the oxygen before you put it through the calcium hydroxide?
No, you don't have to stir it. If you put it under slight pressure, it will mix itself with the compound. So if you have some fan pushing the air through the scrubber, that's sufficient. Now that'll remove the CO2, but it doesn't remove the particulates. So if you want to scrub and filter, you need both a scrubber and a filter. And I found out that there are new kinds of scrubber materials that, much like a swimming pool filter, can be back flushed. You can back flush the scrubbing material, but if you're in a closed environment like a space capsule, where are you going to back flush it to? It's just going to put it back in the cabin. So they just replace the scrubbing canisters or cartridges after they get to peak concentration. But here on Earth, if we want to do large scale removal, we can actually back flush it and then sequester the carbon dioxide. Now, if you want to take it a touch further, I mentioned that you can electrostatically charge the material in your HEPA filter to make it cling to fine particulates. But you can also use a corona wire, the same thing that you would use in your laser printer, to charge the air. It's kind of like lightning, but not so high as it creates the spark. So you're charging the air to make the particulates cling to the corona wire or the corona plate. So all air entering a device that has one of these ultimately will, pick up the gunk from the air. And if you don't discharge it, the air that you're exiting from your electrostatic filter will actually charge the air in the room and charge all the surfaces that the air comes into contact with, because it's discharging onto the surfaces. If you've ever seen one of these early ozone generators, kind of like the early ionic breeze, if you were a smoker using one of these to clear the smoke out of the room, it cleared the smoke visually out of the air, but it deposited all the smoke particles on the walls, on the floors, on everything, because the charged air was discharging onto the surface, and then these smoke particles were clinging to it. It created this tar-like gunk on things that made them yellow in color, and then you had to clean it off. So it sounded like a good idea at the time, and they created a product line that could do this, but not good. And we'll get into that one in a moment. But there's a difference between if you charge it and then you don't discharge it and you expel the charged air, versus you charge it, you grab all the particles out, and then you discharge it, and then you discharge the discharged air. So that's the difference between a precipitator and an ionizer. An ionizer will charge it up and then not discharge it. And when it doesn't discharge it, it goes out in the room and causes problems. But a precipitator will actually charge it up, attract it to a plate, and then use a mechanism, either a light or a catalytic converter, to discharge the air, mostly, before it exits the converter. And I just noticed that Helen says the Lake Nyos disaster was caused by carbon dioxide, not carbon monoxide, and the carbon dioxide displaced the oxygen. So yes, I was wrong. It was carbon dioxide. So a precipitator will charge, filter, and then discharge the air. An ionizer will charge, pick up the particles, and then release the charged air in the room. That was the initial version of the sharper image ionic breeze. And if you've ever looked into how an older laser printer works, they used a corona wire, which produced ozone. So your laser printer was producing ozone. Your laser printer had a corona wire that was producing ozone, but maybe not so much that it caused a problem until you wanted to do something like an 11 by 17 size laser printer. And now you've got a much larger corona wire. So if a product produces ozone to a greater level than if it were not used, it is an ozone generator, whatever they want to call it in the land of product marketing. If it generates more ozone than was in the air before it was placed in the room, then it's an ozone generator. So even a precipitator doesn't fully discharge the air. So a precipitator is also an ozone generator, but it's not an ionizer because it does attempt to discharge the air. So using ionizing radiation as a disinfectant. This was all the rage of how you can get rid of the big bad coronavirus from your hospital or medical offices or wherever they want to sell you something to do this. Hospitals have done this for a while, except they used to use fluorescent tubes specifically designed to produce a specific wavelength of ultraviolet radiation. Visible blue, purple, or violet lights are not sufficient. So if you're looking at your UV sanitation device that you bought inexpensively, if you can see a blue light and that's how it's sanitizing things, that blue light might as well just be a power indicator because it's not sanitizing jack. If it's producing ultraviolet, it can produce ultraviolet, which the human eye cannot see, in either UVA, UVB, or UVC. If it's UVA or UVB, it's not sufficient for medical sanitation. The sharper image ionic breeze, the later models, the GP models, included a one of these tube lamps that put out UV at 254 nanometers. But if you really want it to be sanitizing, 254 is not short enough. You need a shorter wavelength than that. What the National Institutes of Science and Technology have found is that you need something far into the UVC band at 222 nanometers approximately. And that is good for germicidal effects because it actually destroys cells by way of their genetics because it creates destructive bonds in the nucleic acids of the DNA. So it corrupts the genetics and destroys the cells, and they can't recover from that. So it's not like they're suddenly going to develop an immune response, and haha, you got to make it 100 nanometers, not 222. So the odds on them evolving and surviving this is pretty slim. So even the germicidal UV only works on flat, hard surfaces because the photons can be shaded from deep pores or convoluted contours. The UVC sanitation lamp does not work on, if you think of the room divider in a hospital room, that's cloth. Sorry, it's not going to sanitize that. You better take it out and clean it. Now, when you clean it, the washing machine can actually have a UV emitter in it, and you turn that on for an extended period of time, and it will kill it then, because then it's in solution with the water and the laundry detergent, and it's not hiding inside the pores of the fabric. Anything in the UVC range is not good for human eyes or skin, and it's why when a hospital is sanitizing itself using UVC, they typically close up the operating room and they draw the covers on it so you can't see what's going on inside there. And I also found out that UVC is actually used at a different wavelength because it's in water at 253.7 nanometers. I guess that fraction of a nanometer is really, really worthwhile. But so it's used in water sanitation. But I also found out that ionized oxygen or ozone is also used in sanitizing water. And that was an issue recently in the Orlando metropolitan area where they were saying that they have to not use the oxygen to purify the water. They need to pass a percentage of that onto the hospitals for use in ventilators. And what they didn't tell you was, they're not really using oxygen. They take the oxygen and they electrostatically spark it up and create ozone, and they bubble the ozone through the water to sterilize it. So it turns out that the mercury vapor fluorescence that they use at 254 nanometers for sanitation internally also produce 185 nanometers, which if the air were exposed to that particular wavelength, it would produce high quantities of ozone. Luckily, the quartz tubes that they use in the mercury vapor lamps for UV actually blocks the 185 nanometers. So they're safe, sort of. LEDs, on the other hand, are much more controllable in their fabrication, and you can have a UVC LED, very broadband, 3, 5, 10 watts, very powerful in that wavelength of 260 to 265. So it works really well with LEDs, and they do not emit at 185 nanometers. But what they found out was, there are some organisms that even UVC cannot kill. And for those, we got the X-ray and the gamma. But even after we do that, you're still going to need a HEPA filter to sift out all the remaining toxins from the inside of the cells that you've ruptured. So you still need to wipe the surfaces down, even if you're using UV or X or gamma sanitation of a room. So the uses of X and gamma, cobalt-60 produces X-rays. So they use a cobalt-60 emitter, and then they have it in a location, and then you have a belt that moves the food underneath it. Meats, poultry, seafood, and vegetables are very commonly being sanitized by UVC radiation. It does not make the food radioactive. It does not remove pesticides, antibiotics, or hormones from the food. It just kills the viruses that would otherwise make it through normal UVC processing. But apparently there are some things that get beyond that level. And for that, we've got gamma radiation, literally explode the cells. It works well on hard surfaces like reusable operating room instruments. So, when you see the nurse, and she's the scrub nurse managing the operating room, she takes all of the instruments out of this giant kit bag, and the giant kit bag had gone through gamma radiation in order to sterilize it, as well as autoclave steam cleaning of it, but just to make sure that there's nothing living on those instruments before they start sticking them in. So we've gone from surgeons wearing butcher aprons with human blood and other gunk from the inside all over them. They just wipe their hands on it. That's how surgeons would operate during the Revolutionary War and the Civil War. And after that, they realized probably not a good idea. And now as we go farther and farther along and learn there's more stuff out there, we find that we need more absolute ways to kill stuff. And so we move up from, static charging of the air to suck out the particles, to UVA, B, C, to X-rays, to gamma radiation. You don't want to be doing it with cosmic radiation, because that's basically cores of atoms, and they're actually going to be destructive to the material. Now on to the Sharper Image. So the original Sharper Image company is gone. The stores were closed, and a company called Camelot Venture Group bought up the branding rights, as they say, for pennies on the dollar or a song. So when you see a product that's new in the box and it says Sharper Image on it, the company that's making that product just paid Camelot Venture Group some money to stick the logo on the packaging or on the product. There is still a product marketed as the Ionic Breeze by Sharper Image, but it is not from the original Sharper Image company, and it is not the original Ionic Breeze products. Unless the device actually contains an ionizer wire, a corona wire, which would produce ozone, it's more likely just something that's labeling itself as an Ionic Breeze, but actually just has a activated charcoal HEPA filter inside of it and a washable plate or screen. Any products you want to sell in the US, they are required to be compliant to both federal and California state laws regarding the amount of ozone they can produce. And I've got the ARB specifications here if anybody wants to go look them up. You can look up ARB at the US federal level, or you can look up CARB, as in California ARB, at the California state level. And these are the folks that say the amount of ozone you can have your product producing. I'm sure that all of those more than 10-year-old home laser printers with the corona wires are grandfathered in. So I've got a lot here about the original Ionic Breeze, back when it was produced by the original Sharper Image. It was silent. It did not move a high volume of air. The way that you would point out the weakness of the Ionic Breeze is you would show your air filtering fan that had little strips blowing in the wind of it, and you go, look how much more it moves the air. And the Ionic Breeze people would have the sort of delicately puffing strips coming out of the Ionic Breeze, and they would say, it doesn't blow everything off. So, if you have your high pressure fan, look at the flapping. It's stirring the air and filtering it. And then you have the Ionic Breeze just wiggling. They would say, see, it doesn't blow all the dust off your furniture and circulate it back in the air. Well, if it was really filtering that stuff out of the air, then you'd want it to blow the air off the surface of your furniture and then suck it in and clear it all out. But their claim was it saved you money because there was no air filter to regularly replace, and the filter plate was washable. So the pre-2010 models definitely produced ozone. How much? It actually varied by the instance unit because they didn't have any controls on it. But this was the one that I think cost about $200 or $300. If you remember the TV commercials, they always promoted it. They had this little plexiglass box that had a cigarette smoking, producing air in it. And then they would have the ionic breeze suck the air out of it. And it was just like within seconds, clear all the smoke out of the room. But they didn't tell you how much ozone it then put into the room. And they sold it in different sizes. The one that was for personal use, which they had one that was personal for your room, your office space. And then you had another personal one that was for your car and clipped on your air vent and plugged into your cigarette lighter. Usually what they did, they gunked up the interior of your car. Then you had the small room ones, and you could afford those. Those were maybe 200. But then you had the mega ones that stood about 4 feet tall, and they actually had a fan in those to make it look like it was blowing the air around. Those ran $400+. But they produced so much ozone that people with breathing ailments would actually have problems. Joanne supplied me with some of the frequently asked questions sheet from the ionic breeze. I don't know the date vintage because I don't remember seeing a copyright date on the frequently asked questions sheet, but they identified ozone as the fresh air scent found in nature. How could there be any harm in that? Well, yeah, there is ozone in nature, but the level of ozone outside versus the amount of ozone that this sucker was cranking out inside was significantly more inside than outside. So because the technology of producing an ionic breeze was so cheap compared to the list price from Sharper Image, that created the opportunity for a lot of lower priced knockoffs. And even the lower priced knockoffs weren't concerned about the ozone, so they never tested it. So the lower priced models probably produced even more ozone just because they had fewer controls on them. So when the issue came up, Sharper Image created a new generation of ionic breeze. And what they did was they added a catalytic converter, basically a platinuming of the bar surface that would attract the ionized gas, most of it, before it released it back into the room. So it definitely reduced the amount of ozone that was returning to the room. But people complained because now the filter bar had to be cleaned far more often. Yeah, it was a lot more effective. And if you scrubbed it really hard, you would basically sandpaper away the very thin platinum coating and it wouldn't be as effective. So it had its problems. And then they wanted to add even more value by saying, and it'll sanitize the room too. So they added a UV lamp to it. It was going to be the end all of making the air you breathe just that much better. But it created a lot of problems. So they attempted to posture their newer models as, see, it's not as much of an ozone hazard. It produces less ozone, which didn't work for the lawsuits because the lawsuits said, your original one produced ozone and you said it didn't. And now you're saying it did, but buy the newer model because it produces less. So that was confirmation that the original model actually produced more and you're mitigating it. So that just, made the lawsuits go the wrong direction for them. And I think that's why they eventually went bankrupt, is they just couldn't sustain themselves. But instead of a class action lawsuit, everybody was suing them. And then they were using the prior results of the lawsuit being successful to just go, check, give me some more money. Check, give me some more money. So how many people have seen the Dyson Air Purifier? Shades of trying to do the same thing with the same audience, only different. So these are very expensive. And the Dyson fan uses the elliptical fan that moves like a belt with vanes on it around, and you don't have any of those dangerous and concentrating fan blades. You don't see any fan blades, and you can actually have balloons be sucked into and popped out the other side, and the balloon doesn't get popped. See, it reminds me of that little plastic box with the smoke that, it sucks the smoke out of the room. See, it's not going to hurt you. But your average fan with a good HEPA filter is better than this $300 to $700 thing from Dyson, because apparently they put a cheap HEPA filter in them to make it move more air, because a HEPA filter will block air as well as blocking particles. So to have it pump more air out the backside, they don't put as fine a HEPA filter in it. They have a 0.3 micron HEPA filter as opposed to a 0.1 micron HEPA filter. So 0.03% of everything that goes through the Dyson Air Purifier actually makes it back into the room. And the other nifty thing is, if you ever look at an oscillating fan, a fan that sort of cycles back and forth, different models will go different distances. A good one will actually go 90 degrees, so it can catch this way 45 degrees off the 90 degrees, and it can go this way 45 degrees off the 90 degrees, so it can actually sweep an entire room. This sucker doesn't go 90 degrees, it only goes 70 degrees. So it's not going to sweep an entire room. If you're sitting in a chair and you put this thing in front of you, it's good for blowing on you. But they came out with an even more expensive version that actually has a coated catalytic converter in it. And what it does is it takes formaldehyde out of the room. Formaldehyde is CH2O. Isn't that just carbon and water? Yep, that's formaldehyde. Now, what it does do is the catalytic converter takes the formaldehyde and it mixes with water vapor in the air to make CO2 and water. So you're getting rid of the formaldehyde, you're making CO2, water vapor, but the chemical compounding numbers don't come out right. CO2, H2O, that's 3 O's. But formaldehyde only has 1 O. So how do you get 3? Well, it's taking out that much more formaldehyde. No, the CO2 is bonding some of the free oxygen into carbon dioxide. So it's literally taking good air that would have O2 and it's making it into CO2. If you've ever looked at one of those campground catalytic heaters that don't have an open flame, you'll read the fine print and it says, not good for use in tents. Because what it's doing is it's taking the free oxygen and the catalytic converter is bonding and producing CO2, which displaces the O2. So, for every 2 molecules of formaldehyde, you're losing 1 molecule of oxygen. Okay, that's good for free air outdoors, but I'm not sure you want to do that inside of a closed room. I would still think that an electrostatically charged HEPA filter with a reasonable fan that oscillates to 90 degrees is probably going to be your best bet. Plus, it's going to be cheaper because it doesn't have the funny Dyson elliptical fan. So what is the general requirements for purifying air? Well, a simple fan with a HEPA filter that's good will get rid of it. Get rid of the large particulates by taking out water and bigger bacteria, but it does not remove gases. So let's ignore the gases for a while and just say, occasionally circulate air in your house. So your whole house AC, if you put a good filter in it, and there are actually defined standards for filters. there's an organization called SHRAE, and they have a unit called a MERV, and a MERV value of 13 or preferably 14 is really good. But there's the International Standard Organization, ISO, and they actually have a standard for air quality filtration, 16890. And what they want you to have is not a MERV value, but an EPM1. So I'm guessing that an EPM1 is equivalent to a MERV of 14. The 3M brand would like to introduce you to their own proprietary standard for identifying the quality of their filters. And they will tell you that theirs is the MPR rating, the multi-particulate rating, and the microparticle performance rating. And it should be 2200 or 2800. Well, it turns out that those directly map to MERV 13 and MERV 14. So when you go to the store, just buy yourself a MERV 14 or a 3M MPR 2800, and that'll be a good filter. Now, because they're a good filter, they're going to suck stuff out of the air, which means they're going to get clogged more often, which means they're not cheap and you have to replace them once a month. So go on Amazon, buy a few of them in bulk. As long as they have the correct ratings, it doesn't matter if they say 3M on them or not. If they say they're a MERV 13 or a MERV 14, it's probably sufficient. And change them often. Don't be cheap about it. And if you're dealing with a person that has impairments to their breathing, then they have special needs, and you might have to pay more attention to the kind of air that's available in the room. But even some of the instruments they use have HEPA filters, and change them often. Often, once a month is probably sufficient. You don't need to do it once a week, but at least once a month. Okay, indoor air quality monitoring. I bought one of these thingamagadgets with the do gadgets on it. On Amazon for $35, you can buy S Chenjing from China, sold by Anwick in the US through Amazon, and you can get it with 2 days delivery if you're an Amazon Prime customer for 35 bucks. It's literally, it's a box this big. Can you see the device?
Yes.
Okay. So let's see.
see it.
Can you see the CO2 numbers? This second one here where my finger is. You ready?
Uh-huh.
Did the number change?
Yes, it did.
Yeah, that's just me breathing from a foot away. So I think it works. Some people have looked at this unit and said, well, I've got my, quite a few hundreds of dollars more expensive professional detector, and it seems to be within 10% of it on all the indications. So I'll go with that. I just want to know if it's really bad, I can take action. If it's just a little bit, I can open a door and, let some air through. But you have the display. It has a little USB charging port on the side of it. It's got all these vents on the back, and it actually has multiple instruments inside of it. And it has a power on-off button. It's got a reset button and a calibrate button. So it can internally calibrate itself. But the problem I had was I thought that this little indicator with the green was actually a quality indicator. I don't have to know what all these numbers are. No, that's the battery indicator. If you want to know what quality numbers are, they give you a little booklet. Ta-da! And you have to look it up yourself. So what I'm going to do is I'm going to print a little thermal label and put it on top of the unit so I can then read the numbers. But this is what I use. And yes, it is sensitive enough that 2 feet away, sitting on top of my microwave oven, if I pop a couple of slices of toast in the toaster, after less than 10 seconds, the CO2 number starts to go up by about 100 just from the, charring of the bread. So think about that in your home. Oh, I don't want all that excess CO2 in my house, but I love to have a baked, a fresh oven baked pizza. How much CO2 do you think you're producing? On the other hand, if you have an inductive stovetop, not like one of the inductive hot plates, but the old style like GE oven top range kind of things, the heat from that heating the food, if you're cooking in a skillet, is actually going to produce CO2. But I bought one of those induction plates. So I'd over at Helen's friend's house, and I went, that's cool. So I bought one of those, and works great. And I don't produce CO2 when I cook anymore because I no longer fry things in the skillet. I bring things up to a boil, and if it's something that I don't want to be overcooked, I just don't overcook it. But I heat things in water, and I can drain off the water, and that's more energy efficient and produces less pollutants in my house than what I used to be doing. So, and a microwave oven itself doesn't produce carbon monoxide or carbon dioxide because it's not crisping your food.
I might be producing a lot because on the top of my head, you can see my new microwave,
Yeah.
convection oven, and air fryer. And everything I'm eating the whole week is air fried.
Yes. Now the convection oven and the air fryer, if you're using that to crisp things, to put a nice, lovely brown hue on them, that is introducing carbon dioxide into your house. Now, we've done this for how many hundreds of years, and nobody drops over dead when they're frying up French fries. So, take it with a grain of salt. But if society changes its behaviors to reduce the quantities of carbon monoxide, formaldehyde, carbon dioxide, particulate matter, the back end result may be that 50 years from now, we unexpectedly have a longer lifespan. Kind of like when people cut out eating all the lard and all of a sudden coronary disease went down. Not a lot, a little bit.
Or stop eating all animal food.
Well, there's that too, but
Yeah.
I can't wait for the manufactured animal food.
Oh.
They're
I'm
already
already eating those.
there are no, not that. That's not what you're thinking about. You're thinking about veggie burgers. No. This is actually steak.
Artificial meat.
Yes, steak and chicken that are actually made from steak and chicken tissue that is grown in chemical vats that never saw a cow or a chicken.
Quite disgusting. Yuck.
Well, the beauty of it is no hormones are needed, no pesticides are needed, and no antibiotics are needed.
And now the new idea is that for using insects to make, to use the protein of insects, crunchy.
Japanese do it for the longest time.
I ate ants, and they're delicious with onions and garlic and farinha.
You're obviously not from that religious caste that believes you shouldn't be killing even insects.
Well, I don't know if I can eat them. I need to research where I'm the research, because I think I can only eat fungi and vegetables.
I'm in the hopes that someday I can eat a steak or chicken that didn't come from a cow or a chicken. I'll be okay with that. Going to insects for food is, I'm not sure it's completely being explained. I know that in nations that had a problem finding protein sources, they have eaten insects. And I myself love me a plate of them crawdads. Crawdad etouffee, lovely stuff. You not only get your bugs, you also get spicy sausage. But insects have their own self-defense mechanisms in them. Ants have formic acid in them. That's the stuff that makes the ant sting you when it bites you. Well, when you cook up a bunch of ants, you have a high concentration of formic acid in all those ant bodies that you just dealt with. How do you deal with the formic acid? And, you know, when you eat caterpillars, certain types of caterpillars have very toxic spines on the outside of them. How do you deal with that? So maybe earthworms are best. You know, should be like, what is it? Gawk. The Klingons eat gawk. Your gawk is best served live.
No, you don't say the end of the word, it's got.
Oh, okay. I don't know. I don't speak Klingonese. Anyway,
I'm not exercising, so I forgot a lot of, you know, I need to review my vocabulary.
we need sources of protein. We need sources of carbohydrates. We need sources of minerals. We need sources of certain vitamins. And until we can synthesize all that stuff from what? I don't know. Matter reproducers. There's always going to be, at the end of the human food chain, something dying. It can be an animal, it can be an insect, it can be a plant, but in order for us to survive, you can't drink petroleum directly.
No. As Woody Allen said, the whole world is one big restaurant.
Yes, yes. Or how did Spock say it, Helen?
We
We
all
live
live
off
of death.
We all live off of death. Yes.
Right.
Well, now you could eat it alive like the gawk.
But I posted for you the farofa made of ants that we eat in Brazil. That's the YouTube video that I post on the site. Delicious.
Well,
Remember the farofa that I let you try?
yes.
It's just delicious, like, you know, with the, you know, steak.
Yes, but that didn't contain insects in it, did it? Yeah, I know, you're not telling.
Maybe.
Maybe. I read the outside of the package. It didn't say that. It said it had yucca in it.
Yeah, but you didn't ask what I did with it.
Well, I got it. Oh, when you put it on the food, yeah. I don't know. You go to one of those international cuisine fairs, you never know what you're going to get. If you eat it and you like the taste of it and it doesn't immediately make you sick, enjoy having some more of it.
Yep.
On ozone toxicity, did you list what the results were for that? I don't remember seeing that.
Well, let's see. This particular air quality monitor does not measure ozone. It requires a sensor that's going to be multiple hundreds of dollars to read ozone, and it does not read radon. Those are specialty sensors that cost even more money. But the standard for ozone, yes, CARB. If you go to the California Air Resources Board, CARB, they have the ozone standards there.
Do they also have like what the signs are of you being, I gather that the problem was ozone in the house and you get ozone toxicity.
Yes, and
Yes, like whenever you have 0.1 parts per million, you smell that smell of chlorine, like when you clean the house with chlorine, that's the smell of ozone. When you feel that little smell like of chlorine, is that you're already having like your mucoses, the mouth or the nose is already being irritated, and it's highly oxidative, so it's bad for plants, it's bad for your lungs, it's bad for, this, like if you smell it, if it gets to a point where you smell like the chlorine smell, you better leave the place.
Yes,
So
but
if you
even,
don't smell chlorine,
no. Even if you are not yet smelling chlorine, chlorine is when you should leave the room. But if you smell that, as Sharper Image nowadays calls it, the fresh air smell, as found in nature. If you are smelling the fresh air smell inside your house, that's ozone.
okay,
So
and then it can kill you.
not immediately, but it might affect your respiratory system.
So eventually,
Well, what they're saying is that in light of the pandemic, if you're spending an awful lot of time inside your house, multiple days at a time, if you're feeling a little foggy or lightheaded or something like that, it may be that the air quality inside your house has too much carbon monoxide, carbon dioxide, or ozone in it.
and that's why
Firstly,
you have this qualifier that you went and sent and got, so you would know if you had any of those in your house.
well, yes, I just wanted to make sure because I've been spending a solid week inside my house working on a variety of things, and my house is sealed. So I'm not recirculating outside air. That's by the design of my house. My house was built when they said, oh, you don't want to take the outside and circulate it. You want to seal off the outside. 2 houses ago that I lived in back when I was a teenager, it actually took air from the outside and mixed it with the recirculated air inside. So anytime like something was burning outside or a diesel truck was in the neighborhood, you could always smell it inside the house. And house builders, you got to stop that. So unless you open a window or open a door, supposedly your house is well sealed, which prevents the cross contamination. And also, if you go to the trouble to air condition or heat your home, that it's more cost effective to do it that way.
Did you find when you did your detector that you were having high levels of anything?
I did find that when I was cooking certain things, or when I was making toast, or if I'm just in the kitchen for a while, the CO2 level goes up by about 200. And then if I get out of the kitchen for a while, it goes back down, which my next thought after that was, for $35, this was not a bad starting point. But what I really want to do is I want to get a Raspberry Pi, connect a bunch of sensors to it, have it log data over a several week period so that I can see the ups and downs of the air quality inside my house. And there are YouTube videos of Jeff Gerling actually building that kind of thing.
Is a Raspberry Pi similar to this thing?
Now, a Raspberry Pi is a little single board computer that you have to wire up all the individual sensors, and then you put in the drivers for it, like Windows drivers kind of thing. And then you write some Python scripting software that samples all the data from all the sensors periodically and stores it on a disk file. And then every so often you can read up the numbers off the disk file and then make graphs out of it to see, what days were bad. But that's not something the average person is going to do.
Can I
No.
give a simpler solution?
What's that?
Record the image and make like a sensor reading the image and those numbers, and make the graphics instead for you to go and interface in each one of the sensors. Use image.
Well, I would need something that could read the digital data from the pixel images. And I would need to dedicate a camera just staring at this device.
I guess it would be simpler than having each.
No,
sensor
for me, the sensors and the driver and a Raspberry Pi is simpler. For other
Okay.
people, pointing a camera at it and recording it, that will get you the raw graphical data. But now how do you get digital data out of that?
Oh, I can always get digital data out of anything.
How would you get the digital data out of it without writing some
Like
software to do it?
you can transform anything written down, like a picture or something of a document. You can make that is like apps that you go online that makes that
Yep.
picture become edible data.
Yes, and now you have
OCR something.
yes, now you have one picture that you take every 30 seconds over a week. Go back to that app and just keep doing frame, 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 frame. It'll get boring before you even capture a full minute worth of data.
I have another question about ozone.
Yes,
I can remember in my childhood, you know, that they complained about ozone layer and it was being destroyed.
they
And
still
then-
do.
Well, they complain about it less now. I mean,
Oh,
we take-
no. I recently saw an article that there is
Oh,
a
really?
big,
Okay.
there is a big ozone hole over the Antarctic right now, and they're trying to understand that given that we got rid of most of the ozone-eating chlorofluorocarbons,
CFCs, chlorofluorocarbons.
what is it that's eating the ozone layer now?
Didn't it resolve for a while? Didn't it get less?
Yes,
There was something
Yes.
like a volcanoes helped it and lots of other things helped it. And I thought it was less. Now it's bigger again.
Yes,
that
it's
what you-
bigger again.
So it did get better. And now
Yes,
it's,
for a while it got better. It healed itself. It didn't go all the way completely closed, but it went back to a seasonally acceptable value. But now it's getting bigger again. So we have something else that's been recently introduced into the atmosphere that is eating the ozone layer,
at least in that area. You said, where is that at again?
the Antarctic.
The Antarctic.
Yes.
Okay. So now,
You have two ozone holes, one at the North Pole, one at the South Pole. The one at the North Pole, because the North Pole sea ice is seasonal, it goes away now. But the one at the South Pole, there's always a glacier there. So the air is cooler all the time throughout the year. And apparently it's not cool enough anymore because the heat at the South Pole is actually dispersing the ozone. And we have to find out, what's going on there.
so it may not be like what the other problems we had.
Correct.
Where it was,
It may not be a CFC kind of thing. It may be a global warming kind of thing.
okay. Now, my thought is we can create ozone. We
Yeah.
create it here on Earth and we don't want it down here on the planet. We want it up in the
Right.
sky. There's just no way to get it up there high enough.
Well, you remember me
No,
talking,
because if you think about it, the ozone is heavier than oxygen. So it tends to kind of be balanced down a little bit in the nitrogen and it lowers down because of the mass.
yes,
Now, in the upper atmosphere, it's already there, the oxygen, and the oxygen is kind of being bombarded by the radiation from the sun, radiation from cosmic rays, and then it's producing more and more ozone. It builds up slowly because of that, and that doesn't go down because there the atmosphere is very thin, so it stays there. So that is the toxic that is lower and it stays lower and builds up. And that is the one on the top of the atmosphere that stays there. It doesn't go down because it's very thin atmosphere, just the top layer.
Are they two different kinds of ozones?
No, it's same
no.
kind of ozone, just one is by manufacturing and the needs to be very, very low concentrations near us or plants, anything that is alive. And then that is the natural being fabricated by radiation on the top of the atmosphere. And that one, it builds up slowly.
Because I don't remember, I don't know when we started producing ozone or becoming aware that we were actually producing it here.
It's anything that has like anything that has a little bit of radiation, electromagnetic, like batteries, charging batteries, or any machine that's moving, anything that produces electromagnetic charge can produce ozone. And depending
But
how
we may not
much
have been aware of it. Like, what I'm thinking is when I was younger, I don't think they were aware that we could produce it at that
No,
time.
no, they didn't
When
know
they
of
were
its
concerned.
they didn't know of its toxicity, and they didn't care about the toxicity because the parts per million was low enough. And nowadays we think of big data models, so we look at small accumulating and becoming large. Every electric motor that uses brushes, little carbon brushes, produces ozone. The electric motors that are brushless, as they call them, those don't produce ozone. But
When did these first get developed?
every refrigerator in every house that has a motor in it, and the motor has brushes in it, it's producing ozone.
Okay, so we're
It's a
always
matter of how
having,
much.
and we can't get it up high enough to make a
No.
difference.
No, the ozone that we're missing is at the upper layer of the atmosphere. And remember when I was talking about helium, and I said we can have balloons that get up to a certain altitude before the balloon pops, and we can have rockets that go up and go into orbit. What it's very difficult to do is have something go up, not be orbiting at even low orbit, but even be orbiting below that very fast. We don't have anything that does that. So the place where we would want to inject more ozone or suck out helium is at this no man's land of, we can't get into it because it's higher than balloons and it's lower than rockets. The bottom side of the troposphere and the entire mesosphere.
We need somebody to work on that.
I keep thinking about it. As I mentioned earlier during this session, hey, what amount of gravity would be pulling down on a 1 kilogram spacecraft, a nanobot that was put into a orbit, that then the rocket that put it into orbit fell away, and now it was moving? Would photonic propulsion be able to move it continuously fast enough given its low mass? So I got to crunch some numbers.
Oh, I remember you talking about that, but I didn't realize that's what you were saying. Okay.
Yeah, I want to be able to put instruments initially in the mesosphere. And once I can put instruments there reliably, now I want to do things with them. Like, let's start with first put an instrument there and look at, if I measure it across the entire mesosphere, percentage-wise, it's not much helium, but it's a lot of helium total. The next thing is, once you confirm that, now you want to put something in the mesosphere that can be there for a while and basically process out the helium and then bring it back
You want
down.
to come back here down on Earth.
Yeah, bring the helium down.
Up there.
So
Bring
now we have
helium
helium.
down,
So
then
now
pull
we'll
ozone out.
yes, we want to send the ozone up and bring the helium down. But once we can bring the helium down, helium moves from a non-renewable resource to a renewable resource. Because if we, inadvertently vent it out of an MRI machine or a quantum computer, it'll go up into the mesosphere. If we have some ability to go up into the mesosphere and get it and bring it back down, it's renewable.
Yes.
So I'd like to see helium go from non-renewable to renewable. Because once natural gas wells aren't worth getting because nobody's burning natural gas anymore. And they found other ways to deal with certain industrial processes where you don't need it. Then the only thing left to be valuable from mining from natural gas wells is helium. I guess you could be into argon, neon, xenon, krypton, those kind of things.
But helium is going to be utilized a lot.
Oh yeah, we keep constantly finding new uses for helium, like, I don't know, small size gravity wave detectors. They need helium. And they don't just need helium, they need that original kind of helium, the helium-4.
And we don't use ozone for anything.
Oh yeah, we use ozone to sterilize drinking water.
Oh, yeah, I forgot. You
Yeah.
did say that.
Yeah. Yes,
And-
ozone
and,
has industrial
you said
uses.
also for sterilizing equipment.
No, that was radiation.
Oh, that was radiation. Was it a side effect of? No, something was.
Nope. That was radiation. You use that for sterilizing hospital ERs and medical instruments and things like that.
Okay. So water. So we do need ozone to an extent down here.
Yes, we do need ozone, but not too much.
No.
So here's your conclusions. Human breathable air is a complex set of gases, only a small percentage of which is consumed by human respiration. So, you know, we're not going to do much with the nitrogen and all those inert gases, but the oxygen we take in, we mix that, we do our respiration thing, and out comes more oxygen as well as CO2. And we've evolved to have these particulate filtering mechanisms unless we have health problems. So to remove most of the bad stuff from the air, a good statically charged or activated charcoal, good HEPA filter would be good. Don't go for the cheapest filter you can find. Get one that's at least MERV 13 or preferably MERV 14 and replace it once a month. I know I'm a victim of this because every time I think to go replace my filter, I look up and I go, oh, not today. And then when I replace it, it's all covered with all kinds of stuff. And the filter is actually bowed inward because it's sucking air through all the debris. So I replace the filter and I dispose of it. But I think that if you go to buy a product that is going to clear the air for you, and you speak to the salesperson with enthusiasm about wanting to remove everything from the air, it's like pointing a giant arrow at your wallet. And if you're not careful as to what you're buying, it may be more of a hazard than what you thought you might have had in the air, because it could be creating ozone, or it could be eliminating formaldehyde by consuming O2. And when you do that inside of closed places like houses or vehicles, not healthy. So
The thing is to have a HEPA filter and some kind of circulation that has the outside air filtrated.
Yes. A fan with a good grade of HEPA filter is the starting point, and periodically open a window, open the door, or go outside for a few hours to let things circulate. To, any built up is going to come out. Remember that CO2 is heavier than oxygen.
Mhm.
So if all you do is you open your front door or open your garage door, any high concentrations of CO2 that are in your house are going to roll out at floor level. So you don't even need a fan to push it.
How long do you need to leave the door open for?
It depends how much you have. It's just like a smoke.
I'd say even a half an hour is good.
So if I've never opened the doors to this house for a half an hour, the house that I'm in, and I think it's a sealed house, and it's never, I open the door to let, to go in and out of the house,
Yeah.
It's like, 5 minutes at the most.
Well, the way I deal with that at my house is once every couple of days, I'll go out to the U.S. Postal Service box and I'll get my mail. And I leave the front door open a crack while I go to the mailbox. So I go out to the mailbox, I pull the mail out, I kind of semi-sort it, close the mailbox back up, and then I walk back into the house. So 5 minutes every few
Yeah.
days.
Yeah.
My gas detector has not said my CO2 levels are too high. So I'm going to guess that's enough exchange. If you want to do it longer, if you have an electric garage door opener and you have a door opening out to your garage, then, don't run your car, but open your garage door and open the door that goes to your garage and run a fan that just sucks the air from the inside of your house and blows it out the garage door opening. That
That
will
sounds, wish I had that, but it sounds-
exchange the air rather quickly.
yeah. That won't help me, but it does sound like a good idea.
Yeah.
Sounds like you take a day that you're gonna clean up the house, you open the windows and let the air circulate.
I don't
take
even
a-
think I can open the windows.
You take a day to do what? Clean up the house. Oh,
Clean up?
oh. That's a waste of time.
I
I'm only
like
one
the-
I'm only one
Nope.
person living in the house, but it gets dirty again all by itself.
I know. Isn't that disgusting?
My
I would-
house is almost closed all the time, and when I see it, like today I swept the floor, it's like full of sand, like,
Oh,
Where
sweeping
is
the floor. Imagine all the particulate matter you're stirring up.
yes.
Oh,
Well, I mop later.
a good reason not to sweep the floor.
Yeah. Or a vacuum cleaner. Unless you have a HEPA filter on your vacuum cleaner, you're probably stirring up more particulate matter than is in your carpet.
I'm glad to say I have a HEPA filter on my vacuum cleaner.
Yes, yes. Of course, the recommendation for those people that are concerned with particulate material in your house is a linoleum floor, not even a tile floor, a linoleum floor, because it will collect particulate matter and then you can use a wet mop to clean it up without ever stirring it up.
But not on a tile.
Well, tile, the particulate matter doesn't cling to it. It
Mhm.
sits on top of the ceramics. So every time you go walking by on the floor, you're stirring up the particulate matter.
That's true.
Now, and if you vacuum it, you're really stirring it up. The things that we think are mundane and have no problems, if you think about them enough, they are not mundane and they often have problems.
Yeah.
Of course, that's just me. I think of that about everything, but then I'm also not sensitive enough to go, oh, I'm scared by all the dirt and the strange gases in my house. And that does not make me paranoid because I rely upon my genetics, and my genetics say human beings used to live in caves and they used to live out in the woods. And if you've ever actually been in the woods, people commenting about things like black mold, you do know that in order for wood to decay, mold, and in particular black mold, is a requirement.
Right,
So
exactly.
yeah, it's probably not good to stick your face in it and breathe it, or to be shoving it around so it produces particulates, which those can be unhealthy for you. And if you're scrubbing your bathroom, the chemicals you're using for scrubbing it are probably more toxic to you than what you're scrubbing off the walls. So did I cover everyone's deep inner thoughts about air quality and what's in the air? And
Yes, thank you.
is there anything left to discuss regarding this?
You said up in the, I remember in reading your letter you sent out, you said,
Oh, Monroe, is depleting because of the raising of the temperature of the atmosphere. Why you're saying that? I'm reading here. Ozone depletion is directly related to the temperature in the stratosphere, which is the layer of the atmosphere that is above 10,000 kilometers. So the area.
So you
that
should
we
be able
breathe.
to reach the stratosphere with a helium-filled balloon, or maybe a hydrogen-filled
So-
balloon.
This
And
is
it's
because
temperature. So it's the increasing temperature that's causing the ozone problem.
yeah, so this is because the polar stratospheric clouds, which have important role in the chemical destruction of the ozone, only form at temperatures below minus 78 Celsius. This polar stratospheric cloud contains ice crystals that can turn on the reactive compounds into reactive ones that then rapidly destroy the ozone as soon as the light from the sun becomes available to start chemical reactions. This dependency on polar stratospheric clouds and solar radiation is the main reason that the ozone hole is only seen in late winter and early spring. So it's when you start losing light, you don't have the chemical reactions of the sun.
Okay. So
it's like you have less ozone naturally during the winter in each hemisphere. But then because you have the effect of the clouds and the raising on the temperatures, it gets a little bit more complicated and you start having those reactions depleting the ozone.
So as the upper atmosphere heats up, it gets rid of the ice crystals and allows the sun to deplete the ozone more. And so it's another example of why global warming is a problem.
I have one more question.
Yes.
In a spaceship, what do they are spaceships with people that are in them? What kind of circulation system would they be using?
They use a HEPA filter and they use calcium carbonate or they use sodium carbonate.
And also they use
not sodium carbonate. They use
they also use catalytic reactions to
yes, I was going to say sodium hydroxide, lye. So they use calcium
no,
carbonate.
I think they use something with some kind of a mineral. It's a catalytic reaction. I don't know if it's lithium or silver or something like this. They use a metal to do catalytic reactions for oxygen too.
To produce oxygen or to clean the CO2 out?
I think, I'm not sure.
Okay, here it is. So the Apollo and the Mercury and the Gemini used calcium carbonate to remove CO2. The current missions use sodium hydroxide, lye, drain cleaner, as the replacement for it. Apparently it's more effective. Lithium hydroxide is a precursor cathode material for lithium ion batteries. So,
thank you.
So much information, so little time.
Yes. Oh, they
So
have
true.
like the whole cycle of the cleaning interactions between components of the ISS and environmental controls and life support systems.
Yep.
It's ECLSS.
Yeah,
So it's a bit complicated because
Yep.
that is. But anyway, they say that the space station smells like dirty socks.
Oh, really? Oh,
Yes.
no.
Well, that's because up until recently, the day wear uniforms that you wore on the space station, you would wear for 3 to 5 days before changing them. And if everybody is required to exercise for at least 2 hours per day, yeah, they get a bit ripe by the end of the recycle period. So they now have newer outfits that have all the necessary chemicals in the material to make them not so stinky. And the good folks at Tide, is that Procter & Gamble? Tide are working with NASA to create a low water utilization washing machine for the ISS.
Well, that might be growth for the world too.
Well, depends upon how low water it is. If it'll recycle its own water, you know, yesterday's coffee is tomorrow's coffee. If it'll recycle the wash water, it's yesterday's washing water is tomorrow's washing water.
I have a picture for you. Maybe you can show everyone. Let me send to you. This one is really cool because you can actually talk about that like in little detail.
Do you have the
Okay.
picture, or do you have the picture, or do you have a link?
No, I will send you the link so you can show everyone. Hold on.
Okay, put it in the chat window.
You know, on this, the one that you're showing right now, scrubbing, you don't
Yes.
have on the problem, I don't think, that says that it's a problem when you're scrubbing. You can get ill from actually scrubbing if you're supposed to dip it. You're not supposed to,
That's a brand name.
right?
Zip, it's a brand name.
Oh,
Yeah.
I thought you said that you're not supposed to mess with it in the sense of actually scrubbing it, because the particles will go in the air.
Oh, no. This is gaseous scrubbing. That's what they refer to it as. When you want to remove certain types of gases from an air mixture, they refer to that as scrubbing. You're not actually scrubbing.
Okay, but we were talking about the
ISS.
no. I understand that this is for the you know what you're talking about there.
Yeah.
But if you're talking about when you were cleaning the breeze, the machines, the ionic breeze machines.
Yes.
That
Yes.
don't. You said to dip those rather than to
Yes.
scrub.
What happened was, in order to mitigate some of the ozone, they put a platinum, they sputtered a very thin platinum coat on the plate. And in order to get all the debris off, people were scrubbing their plates, and there was so little platinum, they were actually scrubbing the platinum off and making them less effective.
Oh, I thought they were getting ill from that too.
No. They were just making the thing that was supposed to be mitigating the ozone less effective.
Take a look in the
Space
picture, shows
station.
in very much detail how is the cycle in the space station. It's actually good because whenever we go to public events, people ask about the environmental control and light support systems. Talk,
Okay.
basically.
I gotta stop sharing.
So what I see here, that oxygen generations is basic water related. So that is no recovering for carbon dioxide. Carbon dioxide is vented or used in some kind of system for produce water.
Now you've got CO2 removal. I notice it says air return. So some of the CO2 is vented
sequestered.
overboard. Some of the CO2 goes in their Sabatier system. I guess that's removing harmful vapors. But
Yeah,
all
and then
these
returns as
arrows,
water.
all these arrows are all over the place. So when you remove the CO2, some of it's used, some of it's thrown overboard, but some of it goes back into the potable water process.
No, the oxygen generation is made by water.
Yeah, they take water and they put it into the oxygen generation, and you have oxygen, and then you have H2, hydrogen. I don't know. It's strange to me to see them venting excess hydrogen and excess CO2.
But if you compare with the atmosphere, you barely breathe like a very small proportion of it, because you have like 20% oxygen depending on the mix that they do that, and you barely breathe any of this. Like it's very
Right.
small proportion, so they can have the luxury of vented out.
Mm-hmm.
Because the problem is the raising of the concentration of carbon dioxide and
Yeah,
not
that's the first one. Now, the other one that they want to absolutely have none of in the air is N2. Not N2, ammonia. NH3? Yeah.
yeah.
The air conditioning system runs off
And
of
free.
liquid ammonia, and you don't want that anywhere around people.
I think the liquid ammonia, it's a outside system. They made the way to cool the space station using that, but it's not a system that can go inside. I think
Mhm.
it's an isolated system. And when I went to space camp, I have to fix that one.
You had to do a
Oh.
spacewalk. You had to do an EVA to do it.
Yes,
Uh-huh.
I did the fixing of the ammonia tank.
Was it hard?
Was because in the space station you have no gravity. I was hanging by cables in a very hot hangar. It was super tough
In a suit.
in a suit, so hot. I have to wear inside of my suit. I have a ice pack suit. I have like a you know those ski resort kind of suits that you have, like it's a long sleeve and like a long johns.
Yeah.
But these long johns have bunch of pockets where you could put your ice pack, especially where you have on your thorax, because that's where you know you don't want to get
Body
hot
heat,
on your
core
head
body heat.
and hot on your core. So that was awful because I have more weight or more mass than me, like maybe almost like maybe 5 kilograms more or 10, I don't know how much, and because of the ice packs, and then you're hanging by cables and trying to fix stuff. Oh, I lost my instruments. I created space junk.
Were you doing this alone, or did you have another buddy to
No,
help
I
you?
have another buddy. You never go by yourself,
I would-
especially because you're hanging on wiring.
Did you have a good buddy?
No.
I figured that probably made it harder.
I didn't have
Yeah.
anybody to read the manual for me, because as you do stuff that is like step by step stuff, and you need to describe the instrument, and then you have to memorize all those acronyms. It's so annoying. So when I went to read my manual for somebody else who was outside doing the spacewalk, I actually said the acronym, and then I described by something that the person would know what it was. So it was, they had like a bacteria samples that they need to move, and I described as eyeshadow packages, and there were two girls hanging. So they understood all the colors and what I was saying. They did super fast because I use analogy instead to use the damn acronyms.
Oh, well, that was good. That was very good.
I guess
It
that's what
looks like eyeshadow.
I guess that's what the commercial space program is going to have to deal with. They're going to have amateurs that don't know all the acronyms, so they're just going to have to explain it. It's the blue round thing.
Yeah, that's what I did.
Mm-hmm.
Looks like a compact.
It works.
It worked. They did very fast. In my case, the instrument got stuck. I lost one instrument. I didn't know the steps that we're supposed to do. I want to do like faster, and then yeah, we didn't finish. The space station lost the heating because we couldn't fix the ammonia tank.
It's kind of like if you've seen the movie Guardians of the Galaxy 2, when they're in the lockup and they're asking the baby Groot, the little tree, to go get something for them. And there's no vocabulary between the two of them. So they're asking for one thing and getting frustrated because he doesn't know what you're asking for. So he keeps bringing you different things. Okay. Any other closing words on this presentation before we start talking about what we're going to be doing in the future weeks?
Did you already turn off the recording?
Nope, because I want to cover what we're doing in the next few weeks.
But what you should
Oh.
do is stop sharing, because then everybody's, what's the name of the family on TV that has the little squares?
Hollywood
It's
Squares.
Yes, the Hollywood squares. You should bring back the Hollywood squares.
Oh,
Oh,
in my
you're doing
spare
3D. Cool.
in my spare time, check this out. This is the gotta wait for it to catch up. This is the 3D model, and you can actually rotate it in 3D. This is my radio antenna.
Ah,
Now, it's right now cylindrical, but I'm going to make it a frustum. And a frustum is nothing more than, think of it like a conical pyramid that the top's been clipped off of it.
It's
And you
gonna
see
be
these- You see these things here?
fractal.
No, it's not going to be fractal. You see these things here? I'll take you back to the raw data. Let's see if I can bring back the raw data. I want the raw data here. There we go. Where's the rest of it? I want the rest of it. There it is. There we go. So this is the
Oh, okay,
raw
got it.
data that I start from. You can see on the outside of it, I have these zigzag patterns. Those are my antenna radiators, but they're not going to be stuck on the outside. I actually want to write the trigonometric formula to wrap them around and into the surface of the cylinder. And they're actually going to not touch each other, but intertwine. You see how the fingers are offset? If I wrap these two down to the cylinder, they'll actually go inside one another and not touch.
Now, last week you showed us one of them, right? That was black.
Yeah,
Now, are
I showed you one of them.
colors are they gonna be different colors, or are they gonna be all?
No, I just used the different colors so I'd know one from the other when I started doing the math. And I go, I need the gray one to be a little more offset or longer or whatever. So yeah, here's the,
So they'll all be like that one.
yes. Except this is a prototype of the shape of the radiator, but the radiators are actually going to be made out of metal, out of probably rosin-free solder, because that's a nice, pliable, cheap metal. But I need to curve this thing around the cylinder. So I need
So that metal,
Radiator. It's not the actual antenna? Monroe, this
What?
is not the actual antenna, it's a radiator.
No, this is the antenna. The cylinder, the cylinder is the body. The cylinder is the body of the antenna.
Okay.
You can see it's
Because
the
you're still
cylinder.
talking about radiator, so I'm like, is that making heat?
No, different kind of radiator.
Oh, okay,
RF radiator.
okay.
Think about a Yagi antenna, like a TV antenna, the boom with the metal things on it that are wide at the back end and short at the front end. This is conceptually the same sort of thing. If you look at it,
Yes.
they're narrow at this end and wide at this end. So this is the back end of the antenna. This is the front end of the antenna. And the front end catches the wide wavelengths, and the back end catches the narrow wavelengths. And you have 4 of them, and they're going to be wired up together. So you have positive phase and negative phase that are merged. So as the antenna gets moved across the sky by the altitude azimuth telescope mount, the antenna itself is going to rotate. You know, when you have a camera on the back of your Altaz telescope mount and it goes across the sky, your image rotates. Well, my RF field is going to rotate. So by having 2 of each phase of the antenna and I merge it all together, the antenna can rotate as it goes across the sky, and I don't have any distortion. So I use different colors for different things so I can tell one from the other. So I've got to come up with, you see how this blue is actually kind of melted into the surface of the cylinder. Well, I need to come up with a trigonometric formula for doing this for the rest of it. Because right now I just sort of pressed it into the flat of it. I actually need to curve it around it.
Do you have to have all of the wider ends at the same end of the cylinder, or could you have opposing sides,
Oh.
like the wide ends at the top and two with the wide ends
Yes.
at the bottom have a much narrower cylinder.
I like
No, the idea is the front of the antenna will be where the wide radiators are, and the back of the antenna is where the narrow radiators are. And ultimately, this won't be a cylinder. It'll actually be a frustum, and the back or the
cone.
narrow, well, it's a cone with a clipped top.
Yeah.
The frustum will have the narrow part, or typically the apex of the frustum would be the narrow part of the wave, and the base of the frustum that would cover the wide part. But I need to wrap the radiators into the cylinder. Initially, I'll start with a cylinder. Once I get that working, then I can do it. And my sort of off the top of my head thought was, I know how to convert Cartesian to polar coordinates, and all I need to do is just, just take the values as I come up with them and wrap them around the radius. Now, why wouldn't that work?
Now you're taking this from one that's already been made.
Oh, no. I'm making this from scratch. I've
Yeah,
done.
but I mean, nobody else has, no other design for this?
There's
And
no other
sometimes you
design.
have,
Okay, there's no other design like this, and for the dirt cheap amateur radio astronomy hobbyist. But the concept of this thing, the zigzag with the wide on the front end and the narrow on the back end, that's actually proven concept, and it was proven at the Green Bank Observatory. And the idea was they would put two of these zigzag patterns together, and they would wrap them onto a cone, and they would put that in where the secondary antenna array would go on a large radio telescope. Because if you looked at a contemporary radio telescope's secondary, you would find that there's a collection of all different kinds of sizes of antennas, because the antennas are cut for specific wavelengths. So you'll find different dishes and rods, and they're all different sizes, and they're all mixed into the secondary, which makes the secondary of this giant radio dish antenna very complicated to create, fabricate, and maintain. By having it all on one antenna, and it picks up a very broadband range of signals, and it amplifies them all. That's what the zigzagging is. That's called logarithmic parameter amplification. You can have one antenna that will pick up a very broad range of frequencies and amplify all of them and come out the back end. And then you just use your tuner to select what you want to listen to. So that's the idea.
so that's a hypothesis that hasn't been done before.
The conical antenna has been done before. The sinuous zigzag's been done before, but combining it as multiple phases and 3D printing it for use by dirt cheap amateur radio astronomers, that's all new. So the fact that I'm merging two different phases together so that as the antenna goes through the altazimuth rotation, I don't have to worry about phase differentiation of the signal. And the fact that the material I'm using for the metal radiators is just some, pliable metal like solder. And I can just press it into the zigzag.
Sounds very complicated.
It's what I do. It's what I do.
It's not so complicated, because the intention is that when you have those zigs that are big, they capture the radio waves that are larger, let's say FM.
Right.
And then you got the zags that are tiny. Those are supposed to catch like a faster wavelengths, like the microwave. So you got larger ones, or the wave that are slower, like radio, and the faster ones like, infrared, microwave.
But you can have one antenna that will capture across that entire bandwidth.
So that's the case.
Now, the other things that I'm adding to this is structural strengthening. If it's just a cylinder, how would you mount that to your telescope mount? Well, obviously you put a Vixen plate on it and, bracket it up like a telescope. That's not going to work, because you want the antenna to be out in front of the mount, because the mount's a big chunk of metal and has motors in it, which creates radio noise. So you want to extend this antenna maybe 2 or 3 feet away from the telescope mount. Well, you can't do that with something that's not rigid. So I create these cross members in it. And then in the center, I put a large diameter cubic shaped strut. So I can drill a hole and then tap a hole, and then I can screw in a large rod, a dowel, and that's what actually mounts to the telescope mount. But then I worry about torsion, rotating. So I put these little wedgie things where it joins up with the cylinder. So you got to think about all those things. And if you want to know all the math that it takes to do it all, there it is. That's the entire antenna right there. And what I had to come up with are the things like translate, which changes your XYZ of where you're going to be drawing it. And then here's another one down here. Where's a rotate? Translate, rotate. Here's a rotate. So you've moved to a certain place on the grid, but now you want to twist it some way. So that's a rotate. But then you want to say, when I draw this, make it a different color so that I can tell one from the other. So I make them different colors. Now, if I get one of them not right, I can tell which one's not right.
What do you call the ziggy thing on the side? That's the antenna, but I thought the antenna is just the whole core. What is the zigzag thing called?
Those are the radiators. That's the metal. That's going to be the wire solder that I just press into the cracks on the cylinder.
Now, do you have control over each one of those individually?
Oh yes. Oh yes.
Okay. Okay.
Yeah, I
All
actually, if you let me see if I can zoom up on these.
Because
That's
I can
not,
see
that's not pixelated. That's actually individual little cylinders that are one after another, after another, after another. And that's what makes up those zigzags. Is I just plop down little things. Because it won't let me draw freehand curves that are mathematically defined. So I have to basically create a couple of thousand slices to make these curves. And then once I get it in the draft mode, this is the draft mode, the way I want it. If you look over here, you can see commands like union and difference. Difference is a subtract. So if I take my yellow cylinder, which is the outside, and then I take my pink cylinder, which is the inside, if I subtract the inside from the outside, I get a hollow cylinder. So that's what the difference is. Difference of the exterior cylinder minus the interior cylinder. So that's how I make a hollow cylinder. But if I want to add things to it, then I do a union. This piece of software is free. It's called OpenSCAD. And there's a lot of 3D drawing programs out there that you just draw. You just, you grab your mouse and you draw with it. And nobody worries about the numbers. But if you want to have 4 of these zigzags be perfectly identical, you worry about the numbers. If you want to have these curves made out of a couple of thousand little slots, you want to write a formula for it. And here's the formula for it. So this is my radiator. I wrote a little subroutine called radiator. And I say, for a specific phase angle, I want to draw a radiator. And I give it the range of dimensions for the radiator, inside and outside. And then I just do a for loop and I draw a whole bunch of cubes. And I keep changing where the cubes are and how they're rotated as I draw them around the zigzags.
I know Helen doesn't think it's that complicated. I mean, I know she thinks it's complicated, but not that. But for me, it's really that complicated. And I'm thinking that this would take a heck of a lot of time. And you've gotten to this point, and how much more time do you expect to spend on it? How much time have you spent on it? I
would say I've spent more time waiting for it to draw things than I've actually spent writing the algorithms.
Oh, that's
you can-
frustrating.
You can find, and I have lots of comments at the front, but I can grab these algorithms off the internet. A damped sine wave, there's actually a Wikipedia page on damped sine waves, and it gives you the formula, and you put in the parameters. So I'm just, here's my comments, and further down, I'm just taking the software and, changing it from a text of a formula to actually a formula with numbers in it.
Monroe, I
Yeah.
posted on the link a picture of the Arecibo secondary with the big one inside, and then the one that looks like a Miyagi one.
Oh, see, now what you're not seeing is if you were able to look inside this dome, you would actually see a bunch of very small antennas. So the primary is down below, you can't see it. And the radio waves go up into a hole here, into the secondary, and then there's a whole bunch of little tiny antennas all cut to a specific wavelength for different tuners.
But you can actually see the larger wavelengths like in radio. You can see with the little spike that you see outside that looks like a Miyagi antenna. You
Yeah.
can actually use many wavelengths with that spike.
Yes, this is a Yagi antenna. You can see that the radiator length is different sizes. Let me see if I can find a picture of Green Bank. Because Green Bank,
Where is that at, Helen? Where was that at?
that was
This is,
Arecibo.
Defunct Arecibo.
That was Arecibo.
It's still hurting my heart when I see that.
It hurts your heart.
Yes.
Yeah, because it's not there anymore. It fell
Oh, it's not
apart.
there.
It
Oh,
fell.
remember-
It fell into itself.
Lack of funding.
Lack of
Lack of-
maintenance.
Maintenance, funding for maintenance.
Yeah.
Yep.
And maintenance is so boring.
Well, see,
Yeah.
here's what happened.
Hating it is so much better.
Here's what happened previously. You'd think they'd learn from it. So this was the initial Green Bank antenna.
But where is Arecibo? I don't know where Arecibo
Puerto Rico.
is.
Puerto Rico.
Oh,
Puerto Rico.
Thank you. Thank you.
Green Bank's in West Virginia.
Okay.
So
thank-
the first large antenna in at Green Bank in West Virginia collapsed in on itself due to lack of maintenance. Corrosion took its toll and it fell in on itself. You think with that fresh in their mind from 1988, they would have maintained Arecibo better, but they didn't want to spend the money.
Science, man.
Now, luckily, Green Bank was still critical for U.S. military research. So, of course, they just opened up the wallet and spent what it took and rebuilt it.
Did they remind themselves to do the maintenance part on it too?
Nowadays, they
fun-
do. Nowadays,
Okay.
they do. But previously, they didn't.
Maybe I said it seems like the design makes it hard to maintain though too.
Well, they're enormous. And they're all made out of aluminum with as little radio blocking metal as you can get. So the dish of it is not actually solid. It's a very fine wire mesh, because if it was solid, the wind loading would be too high.
Yeah.
So you got to think about all those things.
They took pictures of the Arecibo cleanup from satellites. I think you might be able to see on Google Earth.
The cleanup's going to be disappointing. They're just scraping
Yeah.
it all away.
Yeah. Well, is it going to come back again? Do they have funding for it again?
No, it does
I
not
don't
have
think
funding
so.
at this time.
They never will.
Is that because it's radio? It's
No,
Yeah,
it's-
and then
It's that because they don't comprehend the value of it.
of radio astronomy.
No, of that particular observatory.
Oh,
No. It's not steerable. What good is it? Well, it is steerable. You just move the secondary.
Hey, I have kind of a dumb question. What do you know about a Panasonic ERV?
A Panasonic
even though it's
ERV.
ERV.
Yes.
What is an ERV?
It stands for energy. Wait a minute. Energy recovery ventilator.
Not familiar with it.
Whisper comfort, ceiling spot energy recovery ventilator.
There it is. The VLA has them. Oh, now it's not going to show me the picture. I don't want to see a map of it. I want to see a picture.
Oh, that's cool.
Where's the picture? I want to see a picture of the secondary. There it is. So the radio signal comes in, bounces off the secondary, and then goes down to these actual receiving antennas. And you can see they just got a garbage collection of different size antennas down here. So
Okay.
the big dish and the secondary dish are nothing more than radio reflectors. The actual antenna that receives are this collection of junk down here.
Those are the detectors.
Now, the reason why you have so many different ones is because you want a broad range of radio wavelengths. And the way that we've always done it is you cut the antenna size to match the wavelength you want it to be tuned to, as opposed to the contemporary way, which is you have a software-defined radio tuner and you make everything come in and you just select out what frequencies you want to listen to.
Okay.
So if you only had one antenna down here, it was very broadband and could amplify signals as this tall one could. It cleans up a lot of this stuff down here and it's very simpler. It's easier to deploy them. Your radio antenna station can now receive a much wider range of signals. Here's just one of those antennas. This is on the back side of it. This large conical shape right here goes down into the backside of the antenna. And this is what's on the other side of the backside, is this giant metal cone. And the detector is actually down here in liquid helium.
Oh, I don't think I want to put one of those on my house.
No, that's why I'm building something that's going to be dirt cheap, broadband, and amplifying for your amateur radio operator.
Sally, I found a video explaining the principles of the ERV, the thing that you talk about. I just posted a video. It explains the principles of it.
I don't know if it's something worthwhile to help keep the humidity down in your house.
I remember Les mentioning it, and then he said that saves a lot of energy.
Energy recovery ventilator.
Energy recovery ventilator. One of the guys that was doing dialysis was talking about he put one on his house.
Monroe, have you heard about the perovskite solar panels, like the tiny solar panels?
I can only look at what I'm seeing here and saying, hey, this is how we've done it for the last 100 years. We're going to do it the same way, regardless of whatever technology is coming into being. It's an energy recovery ventilator. I don't know. I'll have to look at it. It looks
I'm
like
going to send for you. This is something else. It's not about the recovery generation. This is like a cool stuff that you can talk about is the other kinds of solar panels, because this is interest from all of us who watch those videos.
Before we go on about the antenna that Monroe is making,
Yep.
Monroe, you're making that antenna that way so you don't have to have as many, you don't have to have more than one antenna by having all this, I forgot what you call this.
I'll get two things out of it. Yes, it will be wideband, so I only need one antenna. It will be small and lightweight because it has 4 phases on it. And the number of zigzags down the length of it will be very high in amplification. And the goal is to be able to receive pulsars with it.
Pulsars. And you haven't received pulsars before?
Yes, but it was very by chance inside of Fox Observatory under the wooden roof. And we received one cycle of a pulsar. I want to receive multiple of it.
No, wrong. I just sent this exactly the same video. I'm gonna send you the correct one.
So what
That
is
is
it?
the one.
HRV. I
You
see
know,
he's doing an ERV. What's an HRV? Because we're talking about ERV versus HRV myth.
Yeah. Well, the HRV is supposed to be maybe for larger industrial things versus the ERV, which would be more for home use.
Wait a minute, we've got another video here, which is ERV/HRV versus a dehumidifier. What's the difference?
Mm-hmm.
but it's good to learn because, you know, basically when you extract air or you extract water from the air, you cool a little bit. And then if you use that water to actually expand, you know, let it evaporate, you cool it even more. So whenever you have any kind of evaporation, you cool whatever you have it. So it's like you put a little bit of water on the top of your skin and you blow it. As it evaporates, it cools.
Yeah, that sounds
It's
like
the
a
same
swamp
principle.
pool, the swamp cooler. This does not sound like a swamp cooler.
This sounds
It's
like a
more
high-tech form. This
technology,
sounds
but
like a
same
high-tech
principle.
form of a swamp cooler.
Yeah. But the same principle. You evaporate something and you cool it.
Well, what she was just describing as if you want to cool your coffee or tea, you blow air over the top of it to cause it to pull heat out of the solution. That's exactly what I started with, where I was talking about helium and the guy saying how we get helium down to within a few millikelvin is basically by radiative convection of helium-3 and a helium-4 mixture. And that's how you get that last few millikelvin out.
Mhm.
That's incredible. So the last one is the new kind of a solar, maybe it's not a new kind, but it's the one that I just saw. It's the new kind of a solar
Well,
cell.
you know, I expect that there's a lot of
I
stuff
didn't watch it.
coming out of the woodwork. When, you know, COVID hit, you know, they're going to have all these, you know, sanitizers and things that will take moisture out of the air so you don't get mold, et cetera, et cetera. But I had never seen one of these on a house or in a house.
It's probably because they're too expensive. It's okay for small industrial sites or maybe even office buildings, but you've really got to bring the price down if you say you're going to buy your normal air conditioning unit and then add one of these things to it. You
Well,
better be
this is
living in a very high-end
for-
neighborhood.
$420, and then you get the kind of a Y-shaped pipe that goes into it to connect the two. You know, you can see the two vents,
Yeah.
and it goes to the outside air.
I'll look at it.
Okay.
It'll either be a follow-up news story next week, or I'll get so enthralled with it, I'll give it its own entire Saturday.
Oh, on that.
So-
I don't know if it calls for
It's
that.
always cool to learn something else.
Yes.
Yeah,
So
I just haven't.
I've been
Yeah.
watching perovskite solar photovoltaics for a while now.
Oh, okay. I don't
The
even know what
the
is it.
idea is it's a multi-stage crystalline solar cell that can actually take in a wide range of light, not only from the front, but also from the back through multiple layers. So it's a very much higher efficiency photovoltaic solution. And they're looking at it as, sure, it can get all the blue light and the yellow light, but it can also suck energy from infrared light, which is what a lot of it is. So yeah, I can see that. But there's also some guys working on the glass that goes in the windows of houses. Apparently, they found a way of putting some materials into the glass that the glass can actually produce electricity and also be tinted at the same time. So they're saying that'll be the next way that the guy comes through your neighborhood and says, "Hey, wouldn't you like some storm windows for only about $1,200 a window?
Yeah.
Hey, wouldn't you like some automatic power generating windows I can replace your existing storm windows.
Yeah, they say this outfit called Y Green is kind of a scam.
Yeah, it is.
Yes,
It,
yes.
The
I
technology, the
think it was-
technology is not a scam. The business model is a scam.
Yeah.
Yeah, they actually borrow money from your taxes. So when you see it, it's like a lot of people are losing their houses because they borrow like they don't know how much it costs because it doesn't cost them directly. And then the next year when you go to pay your taxes, you cannot pay because they're too expensive and you lose your house.
Yes.
Mm. Yeah, taxes, when you first buy a house, the taxes are like out of this world. I think the taxes for mom's house are run over $9,000, which
Yeah.
is what I have to cough up this year.
I have $17,000 taxes. Not for
Yeah.
long though. I have to move. I'm losing my house.
You're not
Wow.
losing it. You just have to sell it in order to bring down your costs.
I
Yeah.
know, but I don't want to sell it. I like the house.
Well, I live in a very old neighborhood. I live in a 3-2 house on a small lot in a suburban neighborhood. My Broward County taxes are about $2,300 a year.
Oh, 2,300.
Yes. Now I have a 2-2 townhouse in a quad up in West Palm Beach, and that sucker's $3,500 a month, and there's not even any ground. There's no grass.
Hmm.
Like,
It's
no,
just
you're in
because it's
Palm Beach.
location.
You're in
Yeah.
Palm Beach. Yeah. And I'm 1/4 of a quad of a building.
Wow.
So it's all a matter of, it's not how expensive your house is or how much land you have or even the neighborhood. It's just how much are the people living in that area willing to pay in taxes?
Hmm. I know.
Anyway,
It's crazy.
Yeah, that's so weird. It's like
so
you
we are
cannot
we are
make
at
improvements.
we are past the bewitching hour.
Oh, okay.
So I'm
Oh,
gonna
yeah.
stop. I'm gonna stop the recording at this point. No, actually, I was going to mention what we're going to talk about in the coming weeks first, because I'm going to start to need help again. That's why I'm thinking of other things. So next week, we're going to have an update on perseverance and ingenuity. I've grabbed the latest stuff from NASA JPL, and it's not just a status update on the rover and the helicopter. It's also an update on what types of science have they done, what data have they garnered from it, and then what conclusions that we've come up to it with. And then I've got the ever being pushed out pan tilt zoom security camera. And I'd like to do that one, even if I have to cover over the LEDs and not put the dome on it. I'd like to do that one in the either during the Fall International Astronomy Day, Saturday, or the International Observe the Moon Night event. So it's either going to be sometime next month. And then in December, I have the James Webb Space Telescope. And sometime in November, I'm going to do the EM drive evaluation versus other forms of electric propulsion.
Yeah, there's a
Sure.
lot of stuff that's coming out now with the climate change type stuff. We're going to see some radical new things come out to save energy.
It's all simply a matter of the percentages. Somebody once said, if you could make every computer on the planet 15% more energy efficient, we'd have no problem with energy production. Because
Huh?
anytime you have millions to hundreds of millions of anything, trimming it down by a small percentage is a significant thing. So if you made every cell phone 5% more efficient, it wouldn't need to be charged as often.
That's true.
So, you know, And if instead of needing a diesel truck to deliver gasoline to a gas station that you then put in your car and burn, you had an electric vehicle, yeah, that would be different. I did notice, and I sent some stuff off to Helen, there's a number of electric vehicle makers in China that are going to be bringing their products to Australia, Europe, and then the US. And instead of your electric vehicle costing $40,000+ at the low end, it's going to cost $20,000. And then you're eligible for that federal EV credit. So look for the prices of EVs to come way down, for internal combustion engines to be far more expensive than EVs. And it's probably going to happen in the next 1.5 to 2 years.
Yeah, I think they just came out, I don't know, Biden or something. I just heard a quick news blip that they were gonna find a way to supplement or to get a whole bunch more recharging stations put in around the country. I know Tesla has like a deal where people can recharge at stations for a year or something after they buy their vehicle from them. But that's been a problem, you know, for a lot of people. Where
It's
do you
not,
recharge?
I can say it's not been a problem for Tesla owners, because Tesla has an internet connection to every one of the cars. And whenever the cars start going places and start using their energy, Tesla goes in and builds a charging station. So it went from, you know, one charging station in all of South Florida. And then a bunch of Tesla drivers said, we're going to do a road trip to Key West. And we don't mind charging up at the hotels, but we'd really like Tesla to put in some charging stations. All of a sudden, Broward County has 5 superchargers now.
What's a supercharger?
That's a charging station where you can charge at an abnormally high rate.
Okay.
So what's happened is Volkswagen came into the US and said, hey, GM, Chrysler, and Ford, I know we're Volkswagen, but you guys are going to need an EV charging network, and you don't want to build one of your own. So we're going to build one. Would you like to buy into it? So when you see a charging station that has the name Electrify America on it, that's actually Volkswagen, and they've charged General Motors, Ford, and Chrysler electric vehicles to charge in those charging stations, which makes the end user cost for electricity in those charging stations very much higher than a Tesla charging station. So what Tesla is doing is they're saying, we're not going to modify the charging stations to accept your charging cable connector. What we will do is we'll make it where you can buy a charging adapter cable and plug into the Tesla charging network. And it does 2 things. It adapts your vehicle to the Tesla charging network. You'll be able to charge up at about 80% rate of what a Tesla vehicle will be, because we have to have our, you know, buyer's edge. But the other thing is we're going to charge you just a pinch more than we charge our Tesla owners. But then any EV can charge at one of the like almost 3,000 Tesla charging stations in the US.
How much does it cost to charge a Tesla? I don't have a Tesla.
The way that they're describing it is, if you were to put a charging adapter in your house, and then you were to fully charge the vehicle at the maximum rate you can do for your house, it's about the same price. So if you said, well, if I spend money with my electrician and I have him put in a 220 volt, 50 amp outlet in my garage, then I can plug my Tesla supercharger into my garage. And it might cost $4 to charge up my vehicle from low charge to nearly fully charged. So if I were to go out there and drive for my normal daily traffic, it wouldn't even cost me $3 to charge up my car overnight. Think about how much gasoline costs, and the price of gasoline is now going up again.
Yeah, but
Well-
what you might consider is like the hybrid, where you can use the electricity in the local driving, but if you're on the road, you might want to be able to have use gas while you're on the road, which
Mhm.
would charge your electrical along the way.
Have you visited a Florida Turnpike rest area recently?
Nope.
All the Florida Turnpike rest areas now have Tesla supercharging stations in them.
So how long does it take to
Well, the
fully-
idea is if you can spend 30 minutes stopping off at a rest area to fill up your gasoline tank and to go grab some lunch, it's about the same 30 minutes to get yourself back on the highway again. So in the time it would take you to go grab a bite to eat, you can plug the car into the charger, come back out, and you're topped off to take you, another 2 charging stations down the road, which is roughly what you do anyway in your car.
yeah.
So they've filled the mileage trepidation gap considerably without people even knowing it.
Yeah, but I don't always stop and eat. I may stop, you
Never
know,
stop to go to the bathroom?
I do stop to go to the bathroom.
Well,
but
there
I
you
don't-
go. When you stop, plug in the car, walk around a little while, get 15 minutes of charge into the car, you're good until the next time you have to go to the bathroom.
Yeah, it's tough on your knees to drive, more than 2 hours at a shot.
Exactly.
And
So all of the mileage trepidation that people have, that's not the problem. The problem right now is the actual cost of the vehicle. And if they can bring in vehicles that instead of costing what a luxury sedan would cost, they cost what a low-end Toyota would cost, now you're talking.
yeah,
You
Yep.
think that's going to happen?
Yes, in the next year and a half to 2 years.
That
Yeah.
the cost will come down?
Tesla will not so much come down as they will produce an entry model just to fill the niche, but there are going to be Chinese car companies selling cars in the US that will be far cheaper than American-made cars. And
yeah,
unless they do something to this credit bill that they're putting together for EVs, they're going to get you your EV credit as opposed to Ford, GM, or Chrysler. So all the effort that's going in right now to say, we're going to prop up the American auto industry by helping to cover the cost of charging stations and by subsidizing the cost of vehicles with tax credits. If they don't close the loopholes in that, China's going to come in and say, good, we can build cheaper than the big three and we can sell them directly to you in your house. We don't need to have a car dealership that you go buy them from.
yeah. Well, I think one of the selling points is they just went self-driving. The beta just went self-driving, and a lot
Yes.
of people are switching over to that. where
Well,
they-
there are still people that are afraid of self-driving. They think it's going to be more hazardous than you driving yourself because somehow they believe that they're a good driver.
I
the-
just came by 95 at the beginning of the meeting. I was,
Yeah.
driving, and I'll tell you, there are idiots out there.
And they're getting more idiotic.
Yeah,
So Tesla has already been monitoring their full self-drive program, and the number of safe miles driven is already far better than human driving.
oh yeah.
So
I mean,
what
people-
Tesla has to decide right now is go back to the US government and say, if we have our improved full self-drive, do we still have to put a rear view mirror and side view mirrors on the car, or are the cameras sufficient? And if the US Highway Transportation Administration says the cameras are sufficient, that will bring down the price even further. And Tesla's already said their entry-level model might not have a steering wheel, a gas pedal, or a brake pedal. It'll be full self-drive at the economy end.
Huh.
I,
Well,
I
I'll
find
tell you,
it hard to believe that it's going to be completely self-drive.
They
Right.
already are.
But I just don't, I don't know. I'm one of those that is, I don't know how that could
Okay,
be.
okay. Go out on YouTube and do a search for Tesla FSD, full self-drive, and watch these things just driving on any kind of road surface, any kind of neighborhood, city, whatever. The thing has been modified to recognize emergency vehicles by their blinking lights.
mhm.
So
If you remember, there was an
you're believing
investigation that
they can do
occurred.
this.
There was
So
an
that-
investigation that occurred that the Highway Transportation Administration wanted to rake Tesla over the coals for hitting a couple of ambulances. And
Right.
it turns out that they weren't recognizing them. They did a modification to the neural network software design, and they ran a few thousand test miles through it. And now all the full self-drive vehicles can recognize emergency vehicles.
Well,
This is the-
theoretically, you could have your car take you to work and then go back home. So you wouldn't have parking at work and have to pay for parking at work.
Well, they're now saying that if the, whatever they call it, Tesla Model 2, the cheapy Tesla has full self-drive as part of the vehicle's design, you won't even need to own a car. What you'll do is you'll have a robo-taxi. So you'll call up a Waymo or somebody like that and say, hey, I need to go to Publix and get some groceries. And the self-drive car will appear in front of your house and let you know on your mobile device, I'm here. You'll jump in the car, it'll take you to Publix, and then you'll release that car. You'll go inside, get your groceries, and another one will be summoned by the app. Another one will show up and take you home. You unload your groceries, and then you let that car go. No insurance payment.
It's hard to unload the groceries. There should be a robot in it. that will bring the
Yeah,
groceries.
we're getting there. We're getting there. I think that what they need is a pallet in the back.
Yeah.
So it lowers the body of the car down to ground level, and you just grab a little wheeled pallet and slide it out, and there's all your groceries, and then they
Yes.
can get the car back on the road sooner.
Yes.
But
Excellent.
they're saying that not only is it the gasoline savings, it's also the insurance savings.
Yeah.
It's the amortization savings. You take an internal combustion engine off the lot for more than 7 days, it drops 20% in resale value.
Yep.
There are Teslas out on the road today that the used vehicle is actually worth more than the new vehicle, because you can get a used one right now, but you won't be able to get a new one until sometime in April of next year, because they sold their production line. All the new models are sold out.
I have the same problem with the PlayStation 5.
Yeah, but that's for a different reason. That's for chips.
Yeah. They're
So
sold
this
out.
doesn't have chips in it, hey?
Well, the
Tesla
cars have computers on board, so of course they'll have
The
chips in
cars
them.
have chips too.
Yeah, that's what I'm thinking. They
Yeah.
have chips. But that isn't causing them a problem.
Here's the funny thing. Vehicle makers like Ford and GM, they outsource all that stuff to third parties. And if the third party has designed a certain circuit board for GM and Ford, they're different circuit boards. So they have different chips on them. So if all of a sudden there's a shortage of a particular chip that's common to both those boards, it shuts down production of both Ford and GM.
Yeah.
Tesla does not outsource their circuit boards. Tesla
Ah.
builds their own circuit boards, so they are free to substitute chips. So if they find a chip that suddenly goes short, they go in and redesign the circuit board and swap out and put a different chip in, and they're back on the road in a month. So a
And that's
lot
what-
of the earlier production
Trying-
shutdowns that have been the Achilles heel of Ford and GM have not hit Tesla. It's only when the core semiconductor fabs got hit with the shortages that Tesla got hit. And they were hit for a shorter period of time. And of course, Elon said, I tell you what, I'm going to go spend $145 million. And next to my plant in Texas, we're building our own semiconductor chip fab. This will never happen again.
Mhm.
So Tesla will soon be driving down the prices of their vehicles further by making their own damn chips.
Wow.
So
Well, we do need more chip factories in this country.
well, we outsourced them all. We said,
I-
oh, those require labor. Labor's cheaper over in South Korea and Taiwan and Vietnam and China. So we don't need to do that stuff here in the US anymore. So Intel and Fairchild and all those kind of guys that used to build parts in the US, Samsung, they built them all overseas. And as soon as the pandemic hit and they shut down all those countries, there was nobody there to operate the semiconductor fabrication plants.
Yeah, a lot of this though can be done pretty much by automation and robotics. And
Yes, but
So-
those plants are not automated enough because labor was cheap. They weren't spending the money for the robots.
Mhm.
I think Tesla's going to spend the money on the robots.
Yeah.
The
Think
way
other
I think
people else
it is sand and raw aluminum will come into one side of the plant and chips will come out the other side.
Yeah.
Well, other companies will follow or not? I mean, did they
Well,
learn?
Intel has already said, we're going to come back and start building plants in the US again. So they've earmarked over $1 billion over the next 5 years to build their first new plant in the US. That's way too little, way too late.
It makes sense with the possibility of quantum computing chips coming in.
I'm not holding my breath on those. The semiconductor circuit at the core of a quantum computer is relatively small. It's about half the size square area of a playing card. But all the other pipes and plumbing and tank for the liquid helium are enormous by comparison. They're not going to make those suckers small anytime soon.
So you think they're going to have them? You just don't think they're going to be available for the general public?
No, probably.
I think they will be useful in certain niche algorithms where if you're a large insurance company and you want to calculate the profitability of a new insurance program, you'll run that on the quantum computer and it will run through the matrix in hours instead of weeks. And that's money in the bank for you. So you don't mind spending millions of dollars with IBM or Google or Honeywell to run some time on their quantum computer, but you're certainly not going to spend $1 billion to go make a quantum computer from scratch.
Yep, but the government might.
Well, the Chinese government found there's a different approach. They went to a couple of universities in China and they said, if we give you millions of dollars, and by millions, I'm talking, maybe tens of millions, not hundreds and not billions. If we give you tens of millions of dollars, can you put all your graduate students and your professors to work on making quantum computers desktop size and with a sufficient number of qubits to make it practical to use them for more applications? And the university said, no problem. How many people can we hire? And they said, I don't know, 100 people. So if all of a sudden a university that has eager graduate students that want to study quantum computing were given $20 million to go off on a spree and build better and better and better quantum computers that the Chinese manufacturing industry can then take advantage of. Yeah, that's the way to do it. Now, what are we doing in the US? We're sitting back on our laurels waiting for Samsung to build new plants in the US and for Intel to build new plants in the US. Yeah, that's not the right approach.
I read the other day that Chinese developers achieved quantum supremacy
Yes,
higher than the previous one.
yes.
So they have the highest quantum supremacy, which is unbelievable.
Well,
Quantum intelligence.
supremacy is a benchmark. You have a fixed algorithm and you run the algorithm through your quantum computer. And if you have longer lived qubits or you have more qubits, it makes your quantum computer quantum times faster. So it's very easy to make an incremental improvement in your quantum computer and sort of beat the pants off the next guy in line for quantum supremacy, because, you know, you're running it fast enough. Your Joseph's junctions are, you know, fractions of a nanosecond in switching delay. So if instead of having 32 qubits, you have 48 qubits, and if instead of the longevity being a millisecond, it's 3 milliseconds, you can very easily achieve quantum supremacy. But they're not going to replace your average Intel x86 or x64 computer in your laptop. Not for decades.
No.
They indicated that, I don't know what problem they were solving, but they indicated that it solved a problem that in 4 hours that would take conventional computers thousands of years.
Yes, they're usually cracking cryptographic encoding. So,
Yeah.
you know, they're
Oh,
out there.
good, nothing important.
Yeah, they're out there
Yeah.
cracking a 256-bit AES encryption that's used in Wi-Fi. And sure, they've cracked it. You do know that most AES Wi-Fi is now 1024 bits, that even the fastest quantum computer can't crack it in a short enough time to make it worth its while. But it's a
Yeah.
good benchmark to run.
I don't know. I mean, that may be true now, but at the time of the Venona messages, they didn't have anything to crack it, but they cracked it later.
Yes, and that's the thing is, original encryption was 32-bit, and just fast regular computers could crack that in hours. So they made it 64-bit, and then supercomputers could crack that in a couple of days. So they made them 128 bits, and then they made them 256 bits, and then they changed the algorithm to AES instead of the RSA, and it just makes the encryption that more difficult to crack. You're probably going to be able to crack 1024 when you have a 2048 qubit quantum computer that has qubits that last for a few seconds, but that's many years away. And they'll have to be liquid helium cooled. So they're not going to be portable by any stretch of the imagination.
Yep.
Anyway,
I'm going to say goodnight. Thank you very much.
I never shut off our recording, so I'll have lots of trimming. I'll shut off the recording now.